no confidence on the wanted to thank the venue for holding us in, also the speakers. Without everyone, it's not possible to have this happen. And obviously, the sponsors, I'm going to name them. It's Succedo, thank you. OpenSUSE, Nextcloud, and CoolThink. Also, there's not many. If you know that you would like to be part of LAS next year, consider telling your company to sponsor us. It's very important for this conference to happen. This is going to be the venue for this today's. It's also only going to be the room. We have the space at the back. The rest of that's our conference. Yeah, Christine.
Thank you. So one quick thing to add regarding the space. We have this one. We have the space behind my back, and the wardrobe that's like in the end of the corridor on the right. Unfortunately, we don't have the co-working space, like where the chairs and the tables are. So please try to remain in this area so we don't destroy the whole place with people around. And yeah, that should be good regarding where what's under our reservation. Regarding the photo policy, we have two lanyards, like two different colors. We have the orange and the red one. People that would like to be photographed, please take the orange one. If you would not like to be photographed, please take the red one, and we'll be mindful, we won't take any pictures. Unfortunately, this year we don't have a photographer, so it would be so helpful for us if you guys can go around, take pictures, and share those pictures with us. It would be very helpful, especially for our social media presence and to attract more people to come and join us and more sponsors. So thank you upfront for this. The other thing to mention, the conference is under the code of conduct, so please try to behave, please use common sense, be kind to each other. That makes the experience way better for everyone, so we would really appreciate that. Another very important thing is water. The tap water here is drinkable. We have some glasses on the kitchen cart, so feel free to take those, or if you have your own bottles, you can just refill your own bottle, that works too. And at the registration desk, we have a donation box if you'd like to donate, and if you'd like to see LAS blooming and having more people and making this even more beautiful in the future, please donate even physically at the box, or open our websites, KD and GNOME. We have a donation, we have a very beautiful donation page there where you can help us with this, and yeah, it would really make a change for us. So these are like some of the main topics that I wanted to cover. Another thing, we have breaks through our conference. Unfortunately, you guys have to pay for the coffee and things that we offer there. Would love to give to you for free, but it has been a little bit tight. So feel free to have coffees there during the coffee breaks. And talking about breaks, right before the lunch, we'd love for you guys to stay around so we can take a group picture. Please, I know that you're going to be hungry and looking forward to have some food, but we'd appreciate if you could stay here and we can just be in one picture. The Wi-Fi, you can see on the front desk, the code for that is going to be Beta House 909 and the exclamation mark. And I think that's it pretty much. Please share your pictures on the social media, tag us, #LAS2026. We'd love to see your moments, and thank you so much for being here. You make this conference so beautiful, and we're so happy to meet you in person. Thanks a lot.
Yeah, Leonard, please come for the first presentation.
Thank you all for having me here. I'm going to talk today a little bit about adding trust to the Linux-based OSs. Just as a background, I'm Matt Puttering. I work for a startup called Immutable, where I'm the chief engineer. I used to be a long-time GNOME and a contributor from like a long time ago. I'm old, you know. Nowadays I do mostly systemd development. In the past years I kind of focused on making like generic Linux a little bit more secure. So, I mean, among many other things, but this was kind of the main theme, I guess. That means CPMs and immutable systems and things like this. And I think we can see that there's actually a big kind of a development that classic Linux operating systems are slowly moving towards more immutable, more secure, robust TPM-based approaches. I want to talk today about what that means for the desktop and apps. I'm nowadays not so focused on desktops and apps. I'm mostly more on the lower level and server stuff. But with systemd in particular, we try to keep everything in focus and not just have a single focus on lower level. Anyway, I generally prefer, by the way, if my talks are interactive. So if you have a question, interrupt me. I much prefer that than doing it all at the end. We got, I think, I mean, on the schedule it says 60 minutes, right? Like, is it actually 60 minutes, or do I have to? Okay. Oops. Okay. Anyway, so background. So why am I doing all this? I used to travel a lot. I don't quite as much because I have kids now, but I used to travel a lot, including to problematic countries like China, or I was in Ukraine, not recently, but yeah. And I had some interesting experiences there with laptops, which I took there, and then when I came back, all the screws fell out at the same time, and it was like something was fishy there. So most likely, the devices may have been tampered with. I did leave them in hotel rooms unattended, but who knows, right? Like it's very, very hard to figure this out. Like for example, one laptop that I took to China and then back to Germany where the screws all fell out. I tried to analyze it with some friends, like what might have happened there. Like they actually, what would an attacker do when they do this? We couldn't find anything. Right? My educated guess is that they probably reflashed the EC or something like this, which I can never physically see. But yeah, and I had some other experiences like this. So I kind of got. Let's not say paranoid, but it kind of made me conscious about like all the security implications there are. I mean, on one hand, this is what happened. On the other hand, I'm an open source developer, right? Like most of the stuff that I did until like so far isn't precisely secret, right? Like it's all code in public repository. But still, I don't know. I like my privacy, and I don't think like I can see how it can be very valuable for certain players to get access to my commits and systemd. But yeah, so I'd like to reduce my exposure. It's in a way it's scratching my own itch, and at the same time everybody else's. I hope, like at least everybody else who wants to travel and is a little bit afraid of people tampering with their devices. So, the primary attack scenario in this context that I was just talking about is the evil maid scenario, right? Like, you leave your laptop in a hotel room, you go out and visit the city, and while you're gone, somebody could copy the disk, or somebody could modify the disk even, or they could modify something else, reflash firmware memory, do any kind of changes, or they can install a keylogger. Like these four things that attacks can do, I think, I mean, the fourth one is actually the worst one because the hardest one to detect, right? Like, I mean, a keylogger is not necessarily a device that you actually find in the USB port. It could be something like hidden on the main board where you do not have the technical capability, at least I don't, to recognize that this happened, right? But the other three ones, like copying the disk, modifying the disk, and refreshing firmware, there are actually technologies around so that we can make this detectable and can protect these things. So let's focus on those. I'd like to introduce a concept called offline security. I mean, I didn't introduce it, other people did, but still explain what it is. Offline security means, like at least for me, means that when data is at rest, it remains confidential, right? It cannot be tampered with. Like you cannot modify it like you cannot read it, but also not modify it. It also means that the OS itself cannot be tampered with, right? So you cannot just change the disk and backdoor it. And that there's always the ability to reset something to a defined state again, right? Like, so if you have suspicion that even though these protections, the first two protections are supposed to be there, maybe they didn't work, you're a little bit afraid, but there's a very, very clear way how you can get back to a clean state, right? These three things, I think, are integral to modern operating system design. We need to make sure that this offline security works, right? So that the data of the user, the OS itself, are protected, and there's always a way to get back to a defined state if something happened. Current Linux distributions, of course, are not like that. There's another term I would like to introduce, which is the state space, right? The space of states that a system can be in. Storage, like disks, RAMs, memory, like memory and CPUs, they all carry state, right? Like they can be in different values, and that's what we call state. It's nowadays computers have a lot of storage, have a lot of RAM, and CPUs have a lot of registers and things like that. So there's a lot of state. The goal with what we're trying to do here with locking down security is reducing that state space, right? So with the goal of robustness and security, we want to drastically reduce the valid states that a whole system can be in. So that, yeah, because they're good states, of course, where the operating system is clean and things like this, and they're bad state, and you want to remove all the bad state and make that an impossibility, right? So I always see anything that we do in the security in this view with immutable systems, with TPMs and things like that, it's like reducing the reachable state space of the system. So after introducing these terms, let's talk a little bit about solutions, right? I mean, let's jump back here. We saw the, where's my slide? Yeah, anyway, so to protect the, that was, yeah. Anyway, to protect the different components of the system, for the local data, we have disk encryption. We have had this for a long time, right? Like LUX in one form or another has been around for 10 years now or something. So disk encryption is great. The OS is much less protected these days, right? Like the goal here is to drastically reduce the state space through authentication of the OS itself. On Linux, traditionally, the OS was not authenticated, meaning that if you make a modification on anything on disk, the system would still boot and would take the modification into account, but there was no form where cryptographic authentication would take place, where these modifications, if they haven't been blessed officially before, would be recognized and refused, right? So if you combine this, the protection of the local data via disk encryption and the OS being in a clean state, you can come up with a model where you say the disk encryption can also lock against the cleanliness of the system state, meaning the disk can only be unlocked if the OS itself is unlocked. And this not only extends to the OS itself, it also extends to the firmware, because on modern laptops, of course, we have a lot of firmware, right? Like there's basically the stuff that we control. Like open source developers, the OS and the apps. But there's also the other stuff that we do not control, which comes pre-installed or under control of the vendor of your laptop. I mean, ideally this was all under our control. We would have all open source firmware and things like that, but this is not the world we live in nowadays. Like if somebody buys a ThinkPad off the shelf, yeah, it's Lenovo's control what firmware runs it, and the same things all the other stuff. If you want to reach the factory reset thing that I had on my slides, the fundamental part is that there needs to be low-level separation of the local data, meaning the user's home directory, meaning /var basically, and the OS itself, meaning the stuff that comes unmodified, ideally from the vendor of the OS, right? So if we do combine all this, right, like disk encryption, authentication of the OS, clear separation of local data from the OS, then we get to this concept of offline security. So let's look at the world how it is right now. Like the first thing is the classic Linux distro OSs, right? Like the classic distribution built on RPMs, built on Debian packages and things like that. It's package based. It's very, very fine grained, right? Like everybody can pick and select exactly the RPMs, the Debian package that they want, and they are combined locally, right? Like meaning on my laptop, if I run a classic Linux distribution, I select these, I don't know, 25,000 packages usually. Put them all together, and this combination is kind of private to me, right? Like there's a very good chance that everybody else in this room who runs a traditional distribution has a completely different combination, right? So it's extremely fine-grained, which can be nice, but also very different, right? Like the packages themselves are also the delivery mechanism, meaning I just download the RPMs as RPMs, authenticate them and install them. So the delivery mechanism is inherently the package. But this all means that the installations all differ in various ways. Like the obvious ones are timestamps, right? Like depending on which order you install the packages and like which, when, like if you skip an update and things like that, the timestamps will all be different. But it's not just the timestamps, it's also good, like because, you know, these RPMs and Debian packages, they typically have these scriptlets where they make modifications on updates because of compatibility reasons, things like that. So they will all run a little different because, I don't know, some people skip certain updates, some people do extra updates or something like this. So we'll slightly do them in different orders. So all the installations will vary in different ways. Also, aborted updates are highly problematic, meaning like you start your update, your power runs out because you didn't charge your battery, and then you have a problem, right? Like because the RPM stuff and the Debian packages not ain't much different. They cannot control, like it's not an atomic operation to install packages. It's a like they apply one package, go to the next, and so on. So and then the file system comes in and might also, because it's not synced to disk, might also lose a little bit. So you have aborted updates are highly problematic. There's a good chance you host your system. If you look on lowest level, right, like if you ED the blocks of the file system on disk, the binary image that you get via that, it's going to vary massively from system to system because all these inputs, different orders, different end times, different combinations of packages and things like this, they will all, like everybody will have a very, very unique file system image. This is not really bad for robustness, right? Like because how do you test for this if everybody has something slightly different? But it also means, yeah, it's very hard to argue about this, right? Like because you cannot say what's right and what's wrong if it's correct that people have different things. The authentication of this model in RPMs and Debian packages is also only and exclusively at download time, meaning you download an RPM, you download a Debian package, you verify at that point in time, then you install it. From that point, you just trust it, right? This contradicts the offline security model that I wanted to go for, because it basically means that if anyone gets access to your system after this happened, they can make any modification they want, and there's no chance in the world how this can be recognized. And there's no real separation of local data from the OS. I mean, there's a little bit, right? Like, meaning there's a slash var, it's usually half controlled by packaging tools and, or maybe let's say 20% controlled by packaging tools and 8% by you and whatever data you put in there. But in general, the separation is very vague, right? Like it's supposed to be that slash user is managed by the package manager, and it's supposed to be that the local stuff is in var, but the lines are extremely blurry, and they're all set on the same file system anyway. And then there's even the other stuff like /boot and things like this and /home. So the separation between local data and from the OS is very, like, there is very little. Meaning that factory set and things like this are very hard to do. So, to summarize all this, it has a very large state space, right? Like every, basically every installation is going to look different, and all of these are kind of fine that way, right? Like they're intended to be that way. So the valid state space is extremely large. There is no authentication of the deployed state, right? Like after installation of all the RPMs, you cannot really make any decision anymore if that's correct or not. You just have to accept it, but only of the input to get to that state, right? Like because that's what RPM and TKG do on upload time. There's no factory set because you can't do this, and the robustness is awful, right? Like because if you turn off the computer at the wrong time, yeah, it gets half updates and it's very hard to recover. And you can hope that the RPM and TKG, when you run them next, will make it worse, but you can only hope. Again, by the way, if anyone has any questions, then interrupt me. I mean, guys are all so silent. Either talking all kinds of nonsense nobody gets, or I'm just a very good presenter. But I doubt that. Oh, there's somebody who asked a question.
Okay, so you said the separation of the data is very important. But what do you think? Well, I think I know where you're going with this. But if you just have a clear separation, so you have the system state, like your operating system in, maybe separate partition or whatever. That you ensure that starts from a clean state every time you boot your system. You can do this with device map snapshot or whatever, or ensure in some other way. You still don't have authentication, but at least you have the factory.
I mean, sure. Like you have a point. You can make this happen with the current design, right? Like you make very, very clear that I don't know, you validate all the RPM scriptlets, for example, that they only that the only thing that ever writes into /user is RPM and only RPM. That you make very clear that the stuff that's written to var is only managed by the installation or something, or and the stuff home is only written by the user context. But it's not that way. If you look at the scriptlets, it's all blurry, right? And so you're right. You can like if you could in theory clean this up. It's just not how this is, right? Like,
I think you don't necessarily need to validate all the scriptlets. You can enforce this separation by simply
yeah, but that's kind of what I'm proposing.
Yeah.
I'm just saying basically we need to put a lot of pressure on this because vector reset matters. You need to be able to reset things back to a defined state and everything's good.
Yeah, well, yeah, I'm kind of describing how template games works in QoS. Where you
Okay, I see you wearing the shirt. Any other question at this point? Okay, let's have another question.
It's possible to sign the current state with intrusion detection environment, so it will be some kind of protected.
So I'm going to, by the way, do I have to repeat the questions here?
It's recording the whole room.
Okay. So intrusion detection systems, I'm not a believer, right? Like because they generally run inside of the system itself, right? And that makes them useless, if you ask me, right? Like because what's an attack gonna do? Like it's first gonna disable the intrusion detection system that you want, right? So the protection always needs to come from some level above the OS or whatever you're protecting, above what you're protecting, so that there's this very clear security boundary between the two, where the stuff that is protected cannot transcend, like cannot go through this, right? So TMs and things like this, they have all these security boundaries, or even kernel and user space would have these security boundaries. But IDS that runs a user space and supposed to protect user space, not announced. Okay, let's continue. So next is the OS style Linux OSs. They have been quite popular. Many of those, I'm not a believer, but you might have guessed that. I mean, the smile face here is supposed to kind of indicate that they're certainly better at some things, but it's not the model that I would advertise. So they're file tree based, right? Like they're not package based, file tree based. They're relatively coarse, meaning that usually the OS itself and the apps, they usually come with runtimes and not individual packages. So these are, it's not fine grained, it's coarse. And they are combined at build time, not at deployment installation time, but at build time, right? Like so the state space is much smaller already because there are not that many packages, so they're not, there's no combinatorial explosion anymore, not bad at least, as with packages. Packages, if they exist at all, are input to the build serve process, right? Not to the individual nodes, but to the build server process. And typically, these OS tree style things, these tarballs, OCI, whatever else, it's all kind of the same thing, which are like files are packaged out in an initialization, and that's it, are the delivery mechanism. It's not packages anymore, and it's not disk images, what we're going to talk later about. It's about tarballs. The file system contents is relatively uniform, right? Like if you download an OS tree app or an operating system built on OS tree, then everybody who has that installed is going to have the same contents of the file system, right? Like, I mean, they still will have 5 apps installed in the OS itself, so there's some state space still available, but it's much, much lower, right? Like because if you look through the file system, if you do like create a manifest of the files there, then everybody's going to have the same hash of that. There are no timestamps anymore. I mean, that's what OS tree does. It sets everything to 0 basically, and everybody gets the same. So that's great. It's mostly safe regarding aborted updates, right? Like it's not fully safe, but mostly safe. Meaning that if you do an upgrade, you just download the newest OCI, tarball, whatever you want to call it, you unpack it, and only after that's complete, you'll switch with the old version, right? Like so that basically limits the window of vulnerability, or what you like, where things are fragile, basically, because all the updating happens atomically, and then there's this one switch of the directories at the end that you need to trust. It's not perfect, right? Like because it relies on the file system not shitting itself, basically, because it's on top of the file system. But it's much better. The binary image of the file system itself, though, it still varies massively, right? Like because I can still skip updates, right? Like I can go from OS tree version 1 to OS tree version 7 or something and skip all the in between. Then that will somebody else will not do that. So that basically means that the writes to the file system will be in a very different order and have much less volume or more volume. And so the binary image of the file system is still going to vary massively. The authentication in these systems is generally also only at download time. Right? Like the tarball is downloaded, is authenticated, is unpacked into the OS tree, then you do switch over, right? Like, but once the switch over, once the download is completed, there's no further authentication. At least that's how traditional OS tree works. There's now the other thing, what's it called again? Where they added via overlay stuff, some access time authentication. I forgot the name. Anyway, complex. So it's that's only much better, right? I'm not a believer though, right? Like because it reduces the the state space of a view on the file system and not as a file system itself. Like from my point of view, this is not great security. There is a much better separation of local data from the OS, right? Like in the sense, because the operating system, the files of the operating system and the apps are going to be as immutable as they can be, and the other stuff is hence the mutable part. So there is a separation. I would call it superficial though, because they're still in the same file system, right? Like, so at block level, everything's going to be different everywhere. So smaller state space, still authentication of downloads mostly. A weak factory set. I mean, it's a better factory set than in the package-based stuff, but it's because there's one. But it's weak, and it's certainly more robust, but not as much as I'd like to be. So this is the second model. Before we go to the third model that I'm proposing, there was a stuff that we're doing, let's talk a little bit more about tags. What it actually means, how you can backdoor a system. So on these traditional systems, like traditional distributions and OSD stuff, the initRDs, the initRD, for those who don't know, it's like it's short for initial RAM disk, even though it's not a RAM disk anymore. But still, like it's the first user space that a Linux operating system starts, right? So it's usually a little bit of a, it's actually, let's call it a tarball, even though it's technically CPIO. It's a tarball that is passed to the kernel. The kernel unpacks into a memory file system, and that then includes basically everything you need to find the real root file system. And that basically means drivers for storage. That means usually also graphics stuff, so that it can do some basic interaction with the system, because you might need to type in passwords, and all the infrastructure for unlocking encrypted disks, meaning TM stuff, meaning FIDO stuff, meaning all that kind of stuff, block stuff, and things like that, right? So that's an initRD. In a traditional system, like both of the ones we talked about, these are not authenticated, meaning they are just files in a boot partition without any further protection. They're trivial to backdoor, right? Like if I leave my laptop in my hotel room, then the attacker can just take my laptop, take the hard disk that's connected to his own system, find the boot partition, modify the initRD, put whatever they want put in there, and just steals all the passwords and sends them off, and it's trivial to backdoor. Honestly, I find it kind of amazing that in 2026 we're still at that point where people deploy a system like this, and we're still at that point where, this is what big commercial distributions all sell you, right?
Wouldn't it just be fixed by disk encryption?
No, because disk encryption is about confidentiality, not about authenticity. Meaning, like you're protecting the wrong way. So cryptographer will tell you do not understand cryptography if you say this. I wouldn't say like this, because of course it does make it harder, right? Because modifying data that you do not know what it is much harder than modifying data where you do know what it is, right? So it's certainly better, but also, what are you going to protect this with, right? Like with a password, sure, that might kind of work, but how do you protect the password query itself? With code from the boot partition. So what did you pay? And you just somebody can still backdoor that stuff, right? Like send everything off, right? Like so, it's no, it's not going to work. Like the way to protect is via TPMs and things like this, and fine. But we'll talk about this later.
Yeah. You will talk about it later, but there is this anti-delay package you can install.
Yeah.
I think it still works also on plain Fedora, not just cubes, which basically use TM to authenticate.
Yeah, but that's what I'm proposing. Okay. Sorry. So once you are in the system, file system changes permanent to the OS in classic systems, right? Like because you have writable file system, can make any change you want, and there's no way how you could prohibit that. Those changes are both permanent for the OS itself and for the local data because they sit on the same file system. So there is no authentication on use basically, right? Like so once the data is on the file system, it's generally assumed to be trusted. At least in the context that it's used. But there's no authentication on use anymore. This is kind of the point that you were asking. LUKS, like the classic disk encryption, is really about confidentiality. It's not about authentication. It will not hinder anyone to change your data. It's just going to make it very, very hard to read the data. And if you have no factory set in any of these systems, then the file system image will always retain a lot of state, even if the local data is erased, right? Like I made this point earlier. Okay, so let's talk about what.
Regarding LUKS and authentication, LUKS tool have space in here also for some data for authentication. It's using DM Verity, I think, or
they combine DM Verity with DM Integrity,
yes.
But it's not the thing that you ultimately want, right? Like, because it allows you to combine detectors from different different write cycles. There's no protection against combining these things incorrectly. So it goes in the right direction. It's not going to deliver you what people actually want. There's actually what you actually want. It's kind of annoying, but anyway. But also, I mean, what it verifies is the integrity of whatever you wrote there. It's not the integrity like authenticating that it isn't to say that the vendor of the OS intended for the developer. Right?
Yeah,
so
but
it's different things.
It should protect about the offline attack, like attacker modifying your encrypted data.
Within boundaries.
Yeah.
Yes. Okay, so what am I proposing? I'm like the modern image-based OSs, I think. So they're kind of related to the OS3 stuff, but they use different mechanisms. So they are disk image-based, right? So instead of sending around file system trees, you send around disk images, meaning like a binary image of a real file system. They are also cores. They are generated build time, much like the file system tree, but the disk images are used instead of the file system trees. The disk images themselves are also the delivery mechanism. You basically give somebody a EROFS or SquatFS, and that's the delivery mechanism. The file systems are completely uniform. Everybody has a bit exact copy that is the same exactly for everybody. So it's not just the contents of the file system, it's the file system itself. Meaning all the data structures are protected. It's extremely safe regarding aborted updates, right? Like because either you have the file system or you don't have the file system. The FS structure is immutable, right? Like you cannot, like it's not going to happen that there's going to be an incomplete update because it just means that either you have the file or you don't have the file. There are only these binary states. The binary images of the file system do not vary, and you can do authentication on every single access with something called Verity, down to the file system blocks, right? Like so, whenever a program wants to read the sector, you can do at that moment you can do authentication to make sure that the sector is actually in that state that you think it should be, which is whatever the OS vendor did. And there's strong separation of the local data from the OS, because now if you basically have if you ship EROS images like completely immutable file system images to everybody, then they can never write to them because the file system inherently doesn't allow writing, and Verity protects us entirely. You cannot write to these files at all, right? So that basically means that when you do allow writes, which you want, because a file system without, like a system without being able to write to it would be pretty useless, and it has to fundamentally be on a different file system, right? Like a ButterFS and not EROFS or XT4, whatever you like. But that also means that there's extremely strong separation between the local data and the OS, right? The OS stuff is all the EROF stuff. The local data is basically everything else. So you can erase everything else and you can only retain the OS and then everything is clear. So it has a much smaller state space, right? Like all the way down to the file system itself. It's now all pinned. Everything is authenticated on access, and there's a very strict form of factory reset. There are a couple of files operating systems that work that way. There's GNOME, for example. Part of the OS is some experiment we started, and the company I founded, Immutable, has the own OS we're working on. They all follow this very, 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 very secure design.
Is the local data authentication anyway? So, for example, the attacker isn't able to change the user configuration and make connect to like wrong server or something like that?
Yes, I mean, this is again like the whole discussion about integrity and confidentiality. But yeah, the goal would be to combine Lux DM crypt with DM integrity, which will not deliver perfect authenticity, right? Like because you can still take sectors and combine them different ways. But at least you know that these sectors must have been written by a trusted system. So we're not there yet in Linux in general to have like the golden standard, like the summit of security, but it can get very close by combining these things.
With this approach, you put a lot more trust on the build infrastructure. What do you?
More? Do we? I don't know.
I think it's if you can build such images, these images reproducibly, you could like independently verify if the build.
Yeah, we can nowadays build these images reproducibly. But you know, people sign RPMs and Debian packages since forever, and signing an RPM and Debian package and signing a file system, not that big a difference.
Yes, yeah. I mean about the verification, if like and detection of compromised build infrastructure. With RPS or Deb, well, it's still not very easy. Like Debian took like.
But still, like all the relevant file systems that you want to use are reproducible and have been reproducible for a long time, right? Like so, the stuff that we build Practical OS with is nowadays perfectly reproducible. I mean, I'm not saying that we actually run checkers for this, but it's there. Okay, I mentioned the Verity thing here, and we talked a lot about Verity. It's a little detour what that actually means. So the Verity is this, in Linux there's something called the Verity. It's device mapper Verity thingy. It's a block level authentication with disk images. It basically just means that, you know, hard disks have these blocks which were traditionally 512 bytes long, and nowadays are more 4K. But yeah, every single block can be authenticated this way. So it builds, and this authentication happens before the data is passed to the file system. Meaning that the file system, you cannot exploit the file system this way if you trust the stuff in block layer already. The protection immutability is it covers the whole file system inside, not just the contents, like what ComposerFS would be doing, but already the file system itself. It's a Merkle tree for those of you who know cryptography, right? It's just a hash of hashes, basically. It's like what Git is. And ultimately, for every disk that you protect this way, you have one root hash value that pins the entire contents of the disk image. The root hash can be signed, right? Like so that you can maintain a local keychain of valid signature keys, and those sign root hashes, and this is how you edit trust. Oh,
so there is also FS Verity.
Yeah.
I think Android uses for.
I'm not a believer.
Yeah.
We can tell.
Does it actually provide some value? But I have the impression it's just pre-computed hashes and speed up hashing of files.
Well, I mean, I think they use it for storing disk images outside of a real file system. I don't see the use case, right? Like because you need a trust to the file system itself, right? Like because it's a primary avenue to exploit the kernel. But then why do you put this on top? I don't know. It's my criticism of ComposerFS because ComposerFS uses FS Verity to get this stuff done. So it doesn't. I don't know. If you do security engineering and then you put it at that level, that seems so weird to me.
All this verification sounds great. No one could object to it. What is the performance implication?
That's a very good question. I mean, there is a performance implication, yeah, but it's kind of small these days because, like, CPUs are good at hashing these days, right? I can't give you numbers, but it's going to be 10% or something like this, which is bad, but it's like, I mean, it depends on the system you have, right? Like, if you have a little Raspberry Pi, it's going to be more impactful, but even Raspberry Pi CPUs nowadays have hashing, complex hashing and things like this. So definitely there is impact, but it's like this modern system is reasonably small.
Does the Verity only support like immutable file systems? Can it also support files that are changing?
No, the Verity, like the root hash basically pins the whole thing forever. It's entirely new, right?
So you can't change the file system.
No, I mean that's what you can use DM integrity for, but again, this is not the perfect solution because it doesn't, like it allows you to combine sectors from different versions together, but it's not that good.
And how does it like exactly work in practice? Like when you open the computer and you enter like some
root password, are the hashes like somewhere internally and then verified internally, or do you have to like have the hash on some extra device?
How this, like, here I'm introducing these DDIs, which are supposed to explain this a little bit. So if we, like in the bigger picture, we're gonna, like in this model, we combine the OS of like purely of immutable verity protected disk images, right? Like we use the verity stuff, we have file systems inside of them, and that's how we compose the entire OS. DDIs are, like we do this for all the base OS images, the extension images, app container images, all as DDIs. A DDI is basically the combination of a file system, like EROFs typically. Could also be squash request. Actually, it could even be read-only X4. Doesn't really matter. In combination with the Verity database that contains the protection data, and then there's a third partition which is basically just contains a little JSON fragment that carries signatures, right? So they basically say this root hash can be signed by this key or something like this, and the key that this is signed with, you basically build into your kernel, ideally, right? But I mean, it's a little bit more complicated for that because you want to have the ability for people to hack the systems themselves, right? Like, so you need a way to introduce stuff. So there's mechanisms for that. But ultimately, the goal is basically the OS vendor has a couple of keys in the kernel. The kernel itself is protected by something else. But yeah, this is how this works. The bigger picture of this is you have all the DDIs, and that stands for discoverable disk image, which basically just means you have these three partitions and you wrap them in a DPT partition header, which is a very simple format just to glue these three things together. So you build a whole system out of DDIs. You combine that as a writable REST for local data on a separate partition, so you get your nice, your really nice separation of state and OS. And through this, you get also something which, like W XOR X, which is like, it's a concept that comes from memory management, and basically just means that something needs to be either writable or executable, but never both, right? So the memory management, this is a very common thing nowadays. Linux implements that for everything, so that you either have immutable read-only code, or you have writable stuff, but then it cannot be executable, right? This is the fundamental step up for security, because it basically means that you cannot just introduce code somewhere and execute it, because if you want to introduce that code, you would have to write it to memory and then make it executable, and that's very, very hard to get, right? So in this bigger picture, we basically extend the concept that memory management people have introduced 10 years ago, something, or 15 years ago, to file systems as a whole, right? Like, for every file that there is, either can be executable and coming from a DDI, or it's writable on a file system, never both.
Question. So how would that influence like applications like flatbacks or such, like users?
Very good question. I have a slide about that. Every file in inode on system can thus be traced back to the DDI it came from, and that's a signature that it came from, the vendor that it came from. Or it is it can be traced back to a local encrypted file system for local state, right? Like then you know that from you, not from the vendor.
Is this writable or executable actually desired property? Because users can write their own scripts, can write application they compile, and it's also acceptable, and they do want to execute it. Right?
Yeah, I mean, this depends on your environment, right? Like if you're a developer, of course you want to be able to write your binary programs from files, right? I think though, like, security is never a binary thing, it's always a gradual thing, right? So the policy that we want to run for immutable OS, for example, is one where on the outermost system, this is going to be very clearly enforced by the security module, by the FLSM thingy. That doesn't mean though that inside of containers, different policies may apply, right? Like because the container world is basically YOLO. The container world just says YOLO, everything can be mixed, there's no distinction between state and code, and all the kind of weird security ideas do not exist. So we say, yeah, as long as that happens inside of user namespace and these isolation frameworks that Linux kernel has, we can relax the security. In an ideal world, even that would be more secure. But on the outer level, right, like with full root privileges, right, we will not allow that, right? Like,
And how do you actually enforce it with, for example, interpreted languages? Like
that's a very good question, actually. But it goes a little bit too much into detail, I think, for my talk. But there is something. It has been a long discussion, basically. But it basically requires support in the individual interpreters. So there's a kernel facility basically where an interpreter like Python, for example, can ask the kernel, shall I be able to execute that script? And the kernel runs its security machinery. It says yes or no. But it's a hack in a way. might be a necessary hack. Honestly, to me, I think we probably should even go for a much stricter policy, even because, you know, for executable code, you should not be able to read it either, right? Like so. But anyway, let's not get lost in
Yeah,
these
that's
things.
gets even more blurry with web browser and JavaScript, etc. So.
Yeah, exactly. Is that HTML page, is that code, or is it
Yeah.
not a document? Who knows? So we can certainly argue about security posture of individual files if we can trace these things back. Okay, next thing, measuring the OS, right? Measuring is a concept where basically the TPM, like this little security chip that you have in your devices, maintains a tamper-proof log of hashes of all DDIs, all images that have been activated on the system. And this measurement is done at the moment of activation of the image, which means basically immediately before the thing is activated. So for the OS image itself, it basically means during boot, we will measure the operating system image itself. This is going to be maintained by TPM. It's going to be tamper-proof. You cannot, after the system has boot up, remove entries from it anymore. It's just cryptographically impossible. But you also do this because we compose the entire operating system just of these images. We do this also for every app that runs, right? So this tamper-proof log of hashes just tells you exactly how the system has been composed, how it has booted up, how it has been running, and every piece of code that ever ran on that boot of the system is going to show up in the tamper-proof log that way. This event log fully describes OS composition with executables and resources. This event log, I mean, sounds like a great idea, we can actually make use of for attestation. So first of all, local attestation. Attestation is basically where you use this kind of log, for example, to as part of the key derivation for disk encryption. So you basically say that the disk, like you have your state, your local state, you want to protect it via locks. So you need a cryptographic key for that. You generate the key on the TPM, and then you say, the next time somebody asks for it, the event log up to that point needs to be in that very specific state. Right? So that basically means that you can say, only GNOME OS systems shall be able to access, if they're booted up very, very cleanly, this disk encryption key that is required to get to my local data, right? This is, I mean, Windows has been doing this for a while. I mean, recently there was a massive security hole where they showed that they didn't do it right. But still, in general, this is not a new concept, right? Like, so basically the TPM allows you, for the keys that it maintains, to have this attestation thing where the system first has to prove that it's in the right state with only clean firmware, with only clean operating system components and everything else that comes in between, right? This is like a fundamental step up, because it basically means that people cannot just take a copy of my hard disk and put it on another system and get access to the encryption keys, because that's impossible, because the encryption key is only available on the TPM and only accessible if the operating system is booted up clean. So goes the theory, at least. Yeah, that's called local attestation because it's between the CPU, the TPM, and the disk, basically, on your system. Often modifications of the OS, if you do them, right, like would modify DDIs, you would modify the Verity, you would thus modify the root hashes of the Verity. This ends up in the event log, this would hence end up in the event logs, and then the disk encryption would work anymore, right? So your data is suddenly protected at risk, and you can only, if you use the right software, get back to it. So great for offline security. There's also another thing called remote attestation. Remote attestation is where this event log authentication doesn't happen on the TPM, but on somebody else's system or some other system. So the event log can be shipped elsewhere. Unfortunately, like the FSF and things like that always say this is bad because this is DRM and things like this. I'm sure you could use it for DRM. Technically, no DRM works like that, but it kind of has political implications to this. But I think this is very narrow-minded because, you know, if that elsewhere is somebody else you don't trust, that's the problem. As long as it's yourself who you trust, this can actually be a really, really good thing. For example, if you have a second device, right, like for example my phone that I also own, and it can validate that my laptop is in the same state, I would feel much more confident leaving my laptop in a hotel room because I can always just check with my phone, which I always have with me, if my laptop's still in the state that it should be, right? So, yeah, the first device is the protected thing, and the second device is the authenticator of that state. I think we could make this actually really nice because we could make it part of the log flow. I mean, this is kind of what Android has been pushing, like with what it's called, but basically where you can unlock a device boot via like an authentication prompt in the phone where you just have to say yes, that's me. So we could make this friendly. This does exist in prototypes, doesn't exist in real life, but I think it would actually kind of useful. Yep.
So 2 questions. What about updates when you do actually intentionally change your DDIs? Do you need like protect this encryption key?
Yeah, update management is difficult, right? Like because you always like this local attestation works only reliably if you can predict what the measurements are going to be on the next boot. We have infrastructure for this, right? Like it's totally doable. It's part of system, for example, system PCR. But basically, you tell this system like, okay, these are all the DDIs that I want to log stuff against, and then calculates basically a decision tree. And then it basically tells the TPM, yeah, this is good state, this is good state, this is good state, this is good state, and then everything else is off limits. So you have a state state space that is more than a single value, but it's not going to explode. It's going to be, I don't know, 16, 20 or something valid states, because we always want to allow the current version of the OS and the next version, maybe the one before, and maybe combine it with firmware states, right? Like so, then you have like 10, 12. Or something combinations, which is still very digestible. So it's not going to be 10,000. It's going to be under 50 by far, like probably around 10.
Yeah, and similarly, what about firmware? If you update firmware,
same thing. It's exactly like you update the OS, so if you update the firmware, yeah, this is going to show up in the event log differently. You need to prepare for that.
Can you pre-compute?
That's a very good question. So there's the problem is generally that we control the OS, we control the bootloader, we do not control the firmware, right? Like so for making updates possible, it's very easy for us to pre-calculate the hashes that the system's going to have when the bootloader is updated or when the OS is updated. It's much harder to pre-compute that for the firmware because the firmware vendors, not universally and particularly on cheap devices, do not give you that. On more expensive devices like Lenovo, for example, does publish some of it, right? Like it's not enough. I think they should do it more, but it's not nothing, right? So the general canonical way out of this, which is what Windows does, is when they expect a firmware upgrade to happen, they basically take out, like they change the access policy of the TPM, basically say, okay, now the volume key can be accessed to the OS and is in order, but the firmware doesn't matter. Then you boot, and on next boot it's going down again, right?
And you hope nobody extra does that.
Yeah, it sucks, but I mean, it's a world living. But again, like with Lenovo devices, like with like the fancy vendors, you can make this better. But we don't actually. But the concept at least are there, and it's kind of halfway hooked up to a FW update key. So if the vendor surprise it, we could, but we never finish the gap. We probably will with.
So what do you think about ERTM, which tries to promise
This goes too much. Let's talk about that thing later. Anyway, I still have I have less than 10 minutes. I just want to cover a couple more things here. Secure boot and verified boot. I mean, secure boot, many of you probably know, it's like this thing that does code authentication at boot and has been like a pain in the ass for about 30 years or something, I guess. It works around code signing. But first of all, what I just told you about the measurement stuff, that's called verified boot, right? Like so that every component of the boot, like the firmware manages the bootloader manages the OS, and then you have a full chain. So that you have the event lock in order, that's called verified boot, right? Like in the event lock you can tie security keys to it. The other thing is secure boot, where basically every boot process doesn't just measure the stuff on the next thing, but it also checks this against the list of valid signature keys, right? I'm not a big fan. They're typically combined, right? Like if people do verified boot, they also do secure boot, but they don't have to, right? Like traditionally secure boot was used alone. You can also use verified boot without. Anyway. Secure boot effectively means on current systems always that you have to basically get your operating system UKIs bootloader assigned by something that's derived from the Microsoft key list. That sucks because first of all it's not very useful, right? Like because everybody can get their stuff signed there. There's very little requirement to get your stuff signed. So at best it's like a super broad allowance of things and just creates bureaucracy. The security value of it is relatively small. So it's a denial list. Yeah. I don't like secure boot very much. It's also very anti-democratic, right? Like, because everybody has to run Microsoft to get their stuff signed. I'm a big fan of verified boot because the policies that do are inherently local to your system, right? Like you own them. They're very democratic. You don't have to ask anybody for anything. You can just put in there whatever you want. So, in the last 5 minutes, let's a little bit talk about what this actually means for desktops. I think it would be great if apps would actually use DDIs, right? The system makes this all relatively easy for you because there's this component system called System Mounted SD, which does all the DI authentication, all the Verity setup, checks against kernel keyring and things like this, and it allows unprivileged, meaning desktop stuff, to do this. So one goal, of course, that I think would be really nice is Flatpak and things like that. Instead of doing OS tree style stuff, would just use DDIs. In system, we also have this thing called System Portability, which is kind of something between containers and apps, but maybe that might also be in the picture. So the traditional drawback of doing this, actually, compared to S3, is that DDIs, they're all separate file systems, right? So separate file systems means that the like if you have the same files that many apps require, and there typically are those, right? Like, I don't know, many images are built from the same libc, so everybody's going to have the same libc SO. And traditionally, if you have them on different file systems, then in memory and on disk, the data is not going to be shared, right? Like, so traditionally this means more expensive disk space, and in particular RAM space-wise. The bigger disk space, I think, sure, is not great, but the memory, I think, is much worse. Because memory is more limited. And it has, like, caching is much worse than things like this. But there's a solution. The EuroFS, like with the primary read-only file system that is in the Linux kernel nowadays, has page cache sharing, where basically automatically, if it finds on the whole system 2 files from an EuroFS image that has the same hash value, basically, will just magically map them together so that any read accesses end up in one of them. So the caching works really nice. The memory maps end up actually with the same apps and everything. So it's kind of magic because it doesn't even require any or much preparation of the people who build stuff. They never have to consciously make sure that these files can be shared, because it just magically work. If there's 2 files ever in any of your images that have the same hash, they magically get be shared. So this is going to reduce the memory use and probably nicer even than OS tree stuff. But disk-based stuff is not addressed with this. We could add infrastructure for that too, but yeah.
Is there a new patch? I remember reading a patch about that where the RFS images had to be tagged. Has it been a new patch since?
Well, you still have to tag them, right? But it's part of the build process. It basically just means that whenever you put an ERFS image together, you also have to calculate the checksum from everyone and put it on the thing. So, but it's just a switch to the file system builder.
Snap relatively close to this model already? Is there basically just signed squash events that they mounted?
Yes.
Could you repeat the question for everyone because they don't have the microphone?
Oh, I was supposed to repeat. I thought I didn't have to. The question was regarding how Snap, like your canonical Snap, actually compares all this. So they use SquashFS, not EuroFS, so they can make use of the page sharing thing. I like many ideas. Like I think snaps are kind of nicer than OS3 in many ways. I mean, even I have a lot of criticism for canonical and stuff like this. I do appreciate that part, but they don't do Verity even things like this, right? Like so. They have like basic, like from my point of view, they got a lot of the basic building blocks right, but never walked the extra mile to actually fit together and take the security benefit home from this, right? So I guess we also had the luxury we are just late, so we can rely on Verity being there, we can rely on EuroFS being there, we can rely on now apparently page cache sharing being there. When they devised Snap, this didn't really, well, Verity did exist, they should have adopted that. They get no excuse for that, but the other stuff didn't. So yeah. I think I got like 2 minutes left.
Yes.
So I have some more ideas where apps could be like the trust model could be made a lot tighter. But actually, I mean, I would rather use the 2 minutes with questions. Unless nobody has one.
Yes, I see a lot about the authenticity of packages and the disk itself, but what about the runtime security? Have you approached the secure glue, for example, to work with them? Or
Secure Blue, that's the thing that.
So it's based on OS3 though, but they have.
But that's the people with the app, right? Like, what was it? Secure Blue?
Secure Blue, yeah.
Yeah.
Yeah, what about runtime security? There are probably interesting.
So I mean, I'm not really that much of a desktop person anymore. Right? Like I do several other stuff. That's the product of Immutable, at least for now. I don't have enough shit on the plate, so I talk to a lot of people, but not to everybody.
So right now in these systems, the shell is not an app. Like when you think about apps as DVIs, does it also include the shell? Because right now it's not run. So like it still can be influenced how the execution of the shell can be influenced by local data, like your .profile.
That's a very valid question. I mean, this is ultimately for the operating systems and I don't know, desktop environments to figure out where do they put the isolation boundaries. Like, for example, you could even do it so that you have a base disk image that does not contain the shell or anything like this. And then the shell is like the first app or extension that you install on it, and then it becomes different. But of course, there are security boundaries everywhere. And but I do hope that at this time, GNOME shell developers or KE shell developers do understand that there's a security boundary between apps and the shell, which wasn't traditionally the way. But kind of Wayland is the written with the security boundary in mind. So I think this is kind of already in everybody's head. But I think my time's over, unless is it actually over? No, it's actually over. So thank you very much, everybody, for the questions.
Hello everyone and good morning again. Welcome to us again, and to everyone watching from home, we are very happy to have you here. We are going to proceed with our next speaker. Thank you very much. This was a very nice presentation to our keynote speaker. We are going to continue with the next talk, and breaking architecture barriers, x86 gaming on ARM. And I'm inviting on the stage. A very quick note, I invite everyone to kindly sit in the empty chairs that are kind of just staying there between the crowds, just so we can let more people in the room. We have a full place, the venue is full for everyone watching at home, so we are trying to kind of use the space as good as possible. So please don't leave the empty seats in the middle, try to go as close to the middle so you can let more space to people joining afterwards. So yeah, the stage is yours. If the audience has any questions, people at home can hear you. So basically, only you will have to read the questions. So I'm sorry about that. And yeah, that's it. People at home who have questions, please send them in the chat. We are keeping track of everything. Thank you.
Well, everybody, I think we're good to go. Yes, okay. Hi, so we're going to talk a little bit today about making x86 applications work on new ARM devices. And I'm actually a little bit interested about my audience here. Like, how many of you are here out of pure interest versus, so quick show of hands, how many of you actually own an ARM device that's running Linux? Yeah, it's about half the room, I would say. The rest I'm going to assume is pure interest. Cool.
Or maybe not Steam Decks.
How many have Steam Decks? Actually, let's do this, okay? And how many of you are going to buy one of the Steam frames that are coming? It's about the same group, perfect. So there's basically two versions of the talk I could give today. There's the very short one, which is you're all Linux app developers, your software is probably open source, just compile your software for ARM and you're good. That's the very short version. Nobody's going to, nobody of you is here today to give that talk. So I'm going to go a little bit out of my way and tell you about our mission to write a software that takes care of 6 existing x86 applications and just makes them work on new ARM hardware. But first of all, a really quickly introduction about who's actually speaking to you. So I'm a hacker turned quantum physicist turned software engineer. Fun CV. I basically got into software development through my work on video game console emulators. So everything from the Nintendo GameCube, Wii, 3DS, and the PSP, something I've worked on emulators for. You might know Dolphin. It's basically like an entry drug in terms of learning how computer architecture works, because it's just so fascinating to me to see that you have these video games from systems that were written exclusively for one platform, but you have the software that's running on PC that magically makes it work on this platform that it was never designed for. And yeah, ever since I learned about the concept, it just hooked me and I kind of sunk into a rabbit hole there. Then I started studying physics, because why not? There's some fun pictures from that era. But nowadays, after uni rather, I decided to go back to software engineering. I started working on Vulkan GPU drivers at Imagination Technologies, and later had the opportunity to work on the Mesa AMD graphics driver as well. And yeah, nowadays I'm working on x86 on ARM emulation in a project called FEX. So what's FEX? FEX is an open source project. We're on GitHub. Exactly what the talk is going to be about, x86 on ARM emulator. And what that entails, we'll see in a moment. But more importantly, we've recently had our 7th anniversary. Yay! I haven't been part of FEX from the very start. I've just joined about 4 or 5 years ago. But yeah, I've lived through a lot of developments, from a proof of concept where we are barely able to do anything interesting to nowadays where we can do much more. More about that in a moment. We will see later, hopefully, a fun demo, which may or may not work. Spoiler, it already failed, so yeah, we'll get there. But let's first talk a little bit about what's actually the scope of our problem here, because there's multiple layers to just x86 simulation. At the very bottom, of course, we have normally our x86 CPU in the system by an AMD or an Intel vendor normally. And on top of that, we have Linux kernel running, which is sort of the base framework for applications. On top of this Linux kernel, we have base libraries like the C runtime, Java runtime, also
the graphics driver and the game engine, like Unity, for example, or Unreal. And only on top of all of these layers we get our actual game that the user is actually having an interaction with. So it's actually quite interesting to already see like the users interacting with this super high level, but the actual components underneath involved are much more rich and diverse than would meet the eye initially. And so, yeah, what do we need to do if we are an emulator? Well, first of all, we need to operate with an ARM CPU. And so we need that's the entry point for any kind of emulator. We need a sort of translation layer between the x86 instruction set and the ARM instruction set. We do this using a concept called binary recompilation, where we basically take the text of one program and translate it to another text. What does it look like in practice? Well, I've prepared a very simple function here, just for instructions that's a toy program. Composed of 4 very simple operations, and what we naively could do is So what we naively could do is directly map this to corresponding ARM instructions, but this is kind of solving everything in one go. We need to decode the binary encoding of the individual instructions. We need to understand their semantics, what they do. We need to find corresponding ARM instructions that match these semantics well. And then in the whole process, we need to make sure that the generated code that we output is also as efficient as possible, because we don't want to just emulate x86 at all, but rather we want to do it quickly, because we want to play games, for example, and not only 10-year-old games, but the latest games possible. And so for this purpose, FEX uses a thing called an intermediate representation, where we focus on the first 2 tasks first. So we want to decode the x86 instruction set and then sort of capture what it does in what we call an intermediate representation, which is just an internal language that FEX speaks that we invented for this specific purpose. And which isn't really optimized for performance or anything, but really just as a more convenient means to operate on this language. If we use this intermediate representation, we can basically do the same thing a normal compiler does. We can optimize this. So we can look for dead source, for constant that could be inline, all that kind of thing. And we can convert this initial intermediate code block into something that is much more compact. Once that is complete, then we are in a perfect position to actually turn this intermediate language into the final ARM code that can run our CPU. So that's a theory. In practice, so it kind of looks like an almost one-to-one mapping. In practice, it's never that convenient. So if you look at an ever so slightly more complicated program, that just does a simple loop, for example, you can see the output already blows up quite a lot. And there's multiple reasons for this. First of all, it's just inherent, like some instructions just don't map that well to ARM. But also, if you look at the very bottom here, there's just a bunch of boilerplate that we need to execute every time we enter and exit compiler box. That's just how emulators work, because we don't know, for example, if the function is returning, does it return to a function we've already executed before, or to something else? And if it's something else we've never seen before, that's where we need to compile on the fly. So that's just, we can't just map it to a return instruction, because we might need to actually jump out of the execution sandbox. And then there's also fun things like what's called flag handling. So whenever on x86, for example, you add 2 numbers and they don't fit into so you add 2 really huge numbers, they overflow. The processor actually automatically detects this and sets overflow flags. It does that unconditionally. You don't opt into it or opt out of it. Whereas on ARM, it is actually opt-in. And that poses a problem for us, because we can't just do more expensive computations all the time, especially because flag handling is slightly different. So simple things like this decrement operation actually turn into these 3 instructions on the right side, where you might have a simple subtraction operation, which just subtracts 1, but then you need the CSAT and the RMI around it for this flag computation overhead. And that's even after our optimization passes already. So normally this blows up to quite a lot, like a 1 to 20 mapping, something like that. We don't have a lot of time for questions, but if it's a quick one, we can fit it in.
Is it possible to somehow figure out which flag is going to be used?
Yeah, we have some awareness across blocks, and that's what allows most of the flag handling to be omitted here. It gets tricky when you're crossing functions, for example, because then you're not able to do like global program analysis, because that would be too computationally expensive, and you might just not have that knowledge. So in many situations, you just don't really get around it. But in these simple cases, and particularly for loops, it can help a lot, yeah. All right. So that's in principle how x86 emulation, as far as the instruction set is concerned, works. The big challenge here is just how tremendously huge the x86 instruction set is. It's always a bit difficult to figure out how to exactly count this, because do you count the actual unique behaving instructions, or do you count the encodings? There's anything from estimates from like 1,000 to 6,000 instructions. And I think, I'm not even sure if that includes things like AVX, for example, so there's a lot to unpack there, basically. But luckily all of that work is behind us nowadays. We are at a fairly complete implementation of the instruction set. We even cover things like AVX and AVX2. As far as I know, was one of the first emulators to even implement these, just because they're such huge instruction set extensions on their own. But yeah, it basically means that nowadays, if you run a game that uses modern extensions, they will still work in Fix. One other tricky issue, if you move beyond pure instruction sets, is the memory model. So that is how the processor actually writes and loads or interacts with your ARM. And to illustrate what the problem here is, I provide a simple example with 2 threads running in parallel, trying to compute some result, just an integer. And to signal that the computation is done, there is a separate variable called just done that just indicates that the computation is complete. First thread does nothing besides initializing the variables and then waiting for the done flag to be set. And the second thread computes the result, assigns it to the result variable, and then sets done to 1. Naively, you would expect that setting done, there we go, that setting this flag would wake up the other thread, and after which it would print the result, which would be 42. And on x86, you would actually be right about this. But the surprising thing, and that is, I should probably stress, is not even including things like compiler optimization or anything. Just inherently, if you side-by-side execute these operations, on ARM that does not actually need to be the case. Because on ARM, what might happen is that the 2 write operations get inverted. Now that's just really a technical difference in terms of how these processes are defined in terms of memory accesses. x86 just gives us the guarantee that variables that you write in a certain order will be visible to other threads in that same order, whereas on ARM that is not given. And working around this on ARM is actually really, really tricky, because you basically need to go out of your way to provide these strong semantics for every single memory access. Even if 99% of your program won't need it, but just this one synchronization primitive might depend on it. You need to add this overhead everywhere, and it basically cuts your performance into half if you naively apply it. So what we did is we add a ton of heuristics on top of this to make sure that the emulation overhead from the memory emulation is as little as possible. So there's a couple of things you can do. First of all, modern ARM processors have extensions like LRCPC that are just a different way of expressing the semantics that are faster to execute on ARM hardware. We can also emulate or implement heuristics like local stack accesses. I'm probably not going to depend on this. And we have really fun engine-specific hacks for Unity, where if we see a relative memory load of exactly 61 bytes, so it's like accessing a certain struct member at offset 61, we consider that critical. So that's an instruction that needs to be adhering to these stronger memory model semantics. But for everything else, we found that Unity games just don't depend on this. So we have this really fun hack effects that if you encounter a Unity game and find these instructions only for those you emulate in memory model, everywhere else we can use the fast path. And it's stupid how well that works, but since it does, and because it affects such a wide range of the game library, we decided it's actually worth putting in like that. So yeah, there's lots of different avenues that you need to tackle this problem on, and there's no one clear solution to it. Right. So that was it for the actual instruction set itself, but as I mentioned before, there's also the Linux kernel itself. And the issue here is that the game thinks it's actually running on an x86 kernel, And while the system call interface is more or less the same, in the details it actually differs quite a lot. So there's minor differences in architecture, and also there is just the fact that we're running in the sandbox. So FX itself needs to be aware of things like threading, for example. So there needs to be an extra layer in between, just so we can track what's actually going on in the emulated application. So that affects things like requests that I just mentioned, but also POSIX signals. It affects file system accesses, because if games want to access a certain library, it needs to see the x86 version of the library and not the ARM build. The system calls that I just mentioned, if the calling convention into system calls is different, FX needs to wrap around that. And then finally, the GPU driver itself, which is actually quite fun. FX actually implements wrappers for every single GPU driver that has an open source kernel driver, so that we can actually run the x86 Mesa drivers as part of the emulation, which will then talk through FX's kernel wrapper to the native ARM kernel, which is, if you think about it too much, it kind of breaks your brain, but it's fascinating that it technologically is able to work. So yeah, we handle all of these things with an additional FX-provided compatibility layer. And I think I'm already running behind on time, so I'm going to speed through this a little. For the system call wrappers, you can imagine it looks like this. So again, we have a block of x86 instructions, and at some point they will invoke the system call, the syscall instruction, which is a special instruction that triggers the kernel processing for the parameter set above. So in particular, the RX register identifies the particular system call that you're trying to call. What we do here is we compile this block of x86 code to ARM again, and then we replace the system call instruction with an external call to a C++ function that we call handle syscall. Handle syscall itself is at that point just checking the ID of the system call and then dispatches it to the appropriate handler internally. The particular handler at the end of the day then tries to decode all the parameters. The details don't really matter here. It gets a little bit, like for most it's fairly straightforward. For some you need to do really complicated repacking, which is annoying to deal with, but not rocket science. The big challenge again is there's a metric ton of these system calls. I had a number, but was it like 200 or something that we need to actually worry about for emulation itself. So again, it's a lot of work to get through all of these and reliably test them and make sure that they actually work for what games need. Yeah, hundreds of things. So, once you implement the binary recompiler for the instruction set, you have memory model emulation in place, and you have a kernel compatibility layer, at that point you're basically done. Because for the actual emulation, actual libraries that run on top of these, you don't really need to do anything more specific, because these are just regular applications as far as X is concerned. They are basically one entity with the game itself, and they just use system calls, they use x86 instructions. There's nothing that differs here from the other code that runs in the application. So, at that point we can put a dividing line here, where you have unmodified x86 software, the application and the libraries, running on top of ARM hardware using an x86 disguise, so to speak, implemented by FX. Right, but there's actually, yeah, okay. So, and that's basically the core architecture of X. That's, if you've kind of lost track now, this is all that's really relevant. It's the x86 emulator and the kernel wrapper. But if you want to be a little bit more efficient, there's actually a few more things you can do. And the first thing is what we call library forwarding, where we found that, for example, the Vulkan driver is very critical to performance, because the games might just fire so many hundreds or thousands of API calls through the GPU driver per second that really starts to become a bottleneck in performance if this is not as optimal as possible. So what we can do instead is, of emulating the full x86 GPU driver, we can inject, because we hook into file system access, remember, we can actually inject our own little Vulkan bridge library on top of the actual GPU driver, which then does spec-specific logic. And spec-specific logic completely bypasses the kernel compatibility layer and calls directly into the underlying ARM GPU driver. Yeah. And yeah, this is essentially just sidestepping a lot of emulation overhead because we don't need to translate the x86 code in the Vulkan driver. We don't need to pay the memory overhead of having the compiled code ring around. And just generally, the code that we end up running at the end is just faster because it doesn't have all the blow up that I showed in one of the first few slides before. And the second thing that we can do is a thing called code caching. Please. Thank you. And that takes care of the overhead of recompilation as well. So basically, whenever we run a game multiple times, we kind of keep doing the same work, right? We already have seen the code before and we translated it to ARM. So why wouldn't we save the already compiled code to disk and save it for consecutive runs so that we don't need to constantly recompile this code? And that's exactly what code caching does. So the first time you run any game, it memorizes all of the offsets that were encountered in the executable and that were executed as part of the game. We store those to a file, and then on the second run, it will precompile the entire thing in one go, so that ideally, during the game, you will not get any studs anymore when you're encountering a new area that you haven't seen before, or your loading times will be much shorter because it doesn't need to precompile all the code again in the first few seconds when opening the game. So yeah, with these two extra components, the goal is ultimately to make FACS as seamless as possible. And for making FACS as seamless as possible, I think a demo would be in order, wouldn't it? So I've given the talk a couple of times now, and I always ask the question, do you want a demo?
Yes.
Yes.
Great. So normally, here comes a big reveal, which is that this is actually the demo, because actually I should mention this. So this presentation is not running, it's not like a standalone PowerPoint presentation or anything, but it is like a HTML website running in Firefox. But it's not any Firefox, it's an x86 build of Firefox running in FACS. Is what I was going to say. And then the demo effect broke. But yeah, I've given this talk 2 times before now, and if you want to look it up on YouTube, there's proof that it used to work. But obviously, just as my luck happens to be, it's like I gave it a try yesterday, and we have some homework to do, I think. So something must have changed in FACS, and it still starts. And I've been able to go through the slide once, but it's a bit finicky. So half of the time it seems to just hang nowadays, so I haven't been able to get it working reliably for the demo today, so I decided to fall back to, I'm sorry, a regular ARM build of Firefox. Yeah. But, of course, that is not the only demo that I prepared. So we shall see if at least the other part of the demo works, because this is actually a really awesome demo. But yeah, also you can see here the hardware I'm using is a Lenovo X13S notebook, which is a bit dated by this point, but it has okay performance for performance cores, all ARM-based of course. And hopefully if we wait a couple of seconds, we will see something pop up. Maybe. Probably should have enabled logging. Oh, nice. So yeah, it turns out we can actually run Steam itself in FACS, which this is actually super cool for multiple reasons. I mean, it's for users, just obviously convenient to have your game library readily available even on your ARM notebook. But what's more is that Steam is actually probably one of the most complicated pieces of software that you're realistically going to try running. Because not only it is like full-blown UI, it's actually based on something like Electron, so a thing called Chromium Embedded Framework, which spawns like an internal sandbox to make sure that games still like randomly modify ID files on your disk. So it triggers all sorts of interesting edge cases, affects this emulation, and it's actually really, really tricky to get working. And that is actually one of the things I've been able to witness as I've been joining FACS development for 4 or 5 years ago. It's just how we got from barely being able to run Steam, like it used to start up in like 2 or 3 minutes back then, and would crash half of the time, to now fairly reliably just working. And of course, we can also play games. Should have started the game while talking and not afterwards.
While we wait.
Yeah.
On x86, Steam is still using quite some 32-bit libraries, right? This is multi-bit things. Is that still the case for the Steam, or is it pure 64-bit Steam?
Don't actually remember because there have been changes recently. But so the question was whether this is actually still using 32-bit libraries. So the game started, but it's on my internal display. Anyway. Yeah, so if there are still 32-bit libraries around, we would be using them, but I don't actually know by heart how many of them. There are certainly components that are 32-bit only, but I wouldn't be able to tell you how many of them. So let's see if I can. Thank you. And yeah, I'm just going to make this really quick to show you that it's actually running. Yay! Really good game, by the way, you should play it. Okay, so to get back on track here really quick, this was the demo. Where's X actually used in the wild today? So there's a couple of venues. The SRI Linux project brings Linux to Apple Silicon devices and was one of the first bigger organizations that started incorporating FACS out of the box to make Steam games playable on macOS and other Apple hardware. Parallels Desktop is using us for something. I don't actually know what, but they gave us credit in one of the blog posts, so we're quite happy that apparently FACS is useful enough to be used in external projects as well. Crossover have started integrating FACS, started working on integration between FACS and Wine to make sure that also you can play Windows applications smoothly. And yeah, as mentioned before, the Steam frame is also quite heavily based on FACS. It's a VR headset developed by Valve that is powered by ARM hardware, so they naturally have an interest in making x86 software work as well as possible, even on this different hardware. And at the point, probably should also disclose that Valve actually kindly has been funding a lot of the work that I've been doing and other people have been doing on FACS, so huge shoutouts to them, and none of this would have been possible without their support. Yeah, and there's actually more organizations that are doing things with FACS behind the scenes. For some of these, I can't talk about them yet, sometimes because it's not public yet, and sometimes because I just frankly don't know what exactly they're doing with FACS. So it's quite nice to see like just the spread, the reach that the software has had at this point. And yeah, so elephant in the room, what about Windows games? Because most games are Windows. So you've just seen Tunic. Tunic doesn't have a Linux port. How did that work? Well, turns out you can just run your favorite puppysimulator.exe game on a regular x86 build of Wine, which then goes through has its own set of Windows libraries. So you just stack the emulation layers basically, running on x86 Linux on the kernel, and you have FACS's wrappers around it to make all of that work. So it just works. Why not? There's a better way though. And just really quickly, how am I on time actually? 5 minutes, okay, I can do that. So, there's a smarter thing you can do. And this is, like, just to give credit where credit is due, what's coming up is now largely based on Microsoft's work actually, because they also have this compatibility layer called Prism, which is also doing x86 on ARM emulation, because they have much larger ecosystem control than we do. They have been able to basically restructure their architecture around it. So the motivation essentially is, instead of running an x86 build of Wine, why don't we compile Wine itself as an ARM library, as an ARM binary? And then, so that already takes care of some emulation overhead. Then we can actually move the recompiler up a couple of layers in the stack and operate directly in Windows executables, where we don't actually compile to normal ARM code, but rather Microsoft invented something called ARM64EC, which is still a regular ARM code, but it's like a custom calling convention that is optimized for x86 operability. And what this allows you to do is just recompiles the game executable itself, and then the recompiled game code can call into a native set of ARM64EC Windows libraries, which Microsoft is distributing as a complete separate set of system libraries. For that, we can completely throw out the Linux libraries because they're just not used anymore. The x86 Linux libraries, I mean. We can also throw out the kernel compatibility layer because there's no Linux libraries that would go through the Linux kernel compatibility layer. And all of a sudden, this whole tower of cards basically condenses down to a fairly compact stack that not only has much less emulation overhead, it's much simpler, faster memory overhead, you know, basically everything that you could have wished for. And so we call this architecture, if you contrast it to the previous one, so just running x86 wine in fact, exactly. To contrast the two stacks, so to speak, we call this other one wine on ARM, kind of an analogy to Windows on ARM, just because it's the same thing, more or less, the same architecture, just with wine at the center rather than Microsoft APIs. So simpler stack with better performance. You can read all about this in more detail in a blog post by one of the core architects of Microsoft, actually. And really quickly, what's next? Because I'm running out of time, I think. We have a lot of work ahead with the Steam Frame launch coming up. We're working a lot with game compatibility, but also performance. So one of the things we've been doing is optimizing floating point performance, keyword there being x87, which is like a specific subset of the x86 instruction set. And we're working a lot on memory consumption. So some baseline workloads that ran at 2 GB before were reduced by literal hundreds of megabytes, just to make sure that even on a low memory budget, you're able to still play your games fluently as you would hope. And yeah, that's all I have for today. If you have questions, come find me after, because I think we're good now. But yeah, thanks all for coming, and yeah. Currently we have time for 1 or 2 questions.
Yes, I have a very complex case. So I got this hardware with DGX Spark, and it's really expensive. So I want to do something else than sometimes running eventually. And I got this idea to run games remotely, and I actually tried this one. And the game I wanted to run was Battle.net, but apparently you can install Battle.net through Steam. So I got this one running, and then I got Steam running and Battle.net over this console game, and with some frozen version it crashed before starting and even past the Battle.net, and with some frozen versions it went up to first loading, crashed. Some others it went up to first loading and then menu, and then I opened again but it crashed. Do you know what's the layer that I should be checking at in this crashing?
We do have an issue tracker where, so I think the core element wasn't the game itself here, but Battle.net specifically, right? Oh yeah, the question was a user when the DGX Spark was trying to run a specific game that was using Battle.net and was crashing in different points depending on what bottom version you're using. And so the question was, where should the user actually try to look into what's going on? And yeah, for games, it's because there's always so much going on, right, on specific games. But we do have an issue tracker that you can check, and I'm sure the Battle.net specifically, there ought to be some mention. Okay. Otherwise, you can come to the FX Discord and just ask, because again, somebody certainly has read this out and is able to.
So it wouldn't be because of the DGX Spark, which is a real ARM architecture with combined video memory.
So I actually have DGX Spark at home, and it's working fine more or less. Yeah.
Okay.
So there's nothing, because FX is hardware agnostic, it doesn't depend on any specific set of hardware. It should work just as well as any other platform. Yeah.
So the Vulkan bridge, is it like an x86 library that internally then switches to ARM code? Like how does it work, right?
Yeah, so the question is, how does the Vulkan bridge work? And indeed, basically for every one of the 2000 or whatever it is Vulkan functions that are, so we have this custom Vulkan bridge library. This is our code, and we basically generate for every single Vulkan function a small stub code that does nothing but trigger FX-specific x86 instructions that tells our JIT, hey, this is the point where you need to do special stuff. And when FX encounters this special stuff instruction, we'll exit out of the sandbox and look up the appropriate Vulkan function on the ARM side of the library. And then so this is a very short version, but all the stuff that happens between deals with calling conventions as well. So the parameters that get passed in actually need to be decoded and repacked. So it's a very involved process, but conceptually we're really just re-exporting all of the Vulkan functions, which stops the trigger execution of the native code. I think that's all. Then again, find me outside for further questions.
Hello everyone and welcome back. I hope you got some coffee. I see everyone here in the room got some coffee, so we're ready to go and start again with the next presentation. Everyone joining online, please send any questions you have, even during the talk. Feel free to send them in the chat, either Matrix or Telegram. We are keeping an eye on both. And everyone in the room, if you have any questions, just be careful to not talk over the speaker, because people online are hearing everything that's happening in the room. So basically, if you ask questions and the speaker is talking, there is kind of some overlapping, and it's going to get a bit messy for everyone watching from home. So yeah, just if you have questions, that's the only thing that you need to be careful of. So yeah, we're going to continue with the next presentation, Flatpak and Portals, status update from Sebastian Vick.
Hi everyone, so I'm Sebastian Vick, and last year at LAS I also had last year I also had talks about Flatpak portals at LAS, and this is kind of a status update of what happened in the last year, and yeah. Also, if you want to reach me, it's also at the end of the slides. So yeah. Okay, so I think this is kind of a summary of like one slide that I had last year, and yeah, let's see. So last year I said like that Flatpak is stagnant. I also told everyone that okay, while it's stagnant, we are maintaining it, we're doing security work. Like it wasn't dead or anything, but there was just not a lot of active maintenance. A lot of feature PRs were just sitting around. Yeah, sometimes even years, and like no one really felt responsible for it. No one felt responsible because essentially the maintainers of the project, they essentially went on to some other things. So yeah, wasn't great, and it also created this weird cycle. There's no maintainers reviewing your PRs. If you want to change something, you're not going to do it, and because you won't get things reviewed, and therefore no one else will start, understanding the code base properly and is able to become a maintainer themselves. So it wasn't really nice. I said that maybe like this is fine. Maybe Flatpak is just going to stay the way it is, and we're just going to use it. Because what's happening is that essentially Flatpak is being used more and more. Like the reality is that even if the Flatpak project itself is stagnating, that people are using more Flatpaks. Flatpak is growing every year. More and more systems are using Flatpaks as their only source for applications. So yeah, I was trying to figure out how we can, with the bit of a weird state that it was in, I wanted to see like how can we continue, how can we actually improve things, yeah, how can we really make progress here, and that's basically where I was last time. And since then, a few things happened. We had a few stable releases, which basically means security fixes and like small bug fixes and whatever. And then for a long time there was nothing. No one felt responsible for doing any releases, so we had not a lot of, we didn't have any releases happening. We were sitting on a stable branch for almost a year, and then I kind of took it on myself to start releases again. So last November, I did the first unstable release, and I completely started doing all the releases of Flatpak. And at this point, I wanted to release like a stable version at the end of the year. That was kind of my goal, but so far that didn't happen. There are reasons for this. But we're close now. We're finally close to like a new release. And because it was taking so long, a lot of distributions started shipping unstable releases of Flatpak, which actually wasn't as bad as I would have imagined. Because it turns out that getting some testing on your stuff is really important. As much as you want to like have unit tests and integration tests and whatever, unless you actually have users actually using this stuff, you won't notice what you need to test sometimes. And yeah, so it wasn't a bad thing that people started doing this, but yeah, also not a great situation because we didn't really intend this to be stable releases. And because we noticed that we really need to get this into users' hands, we also I pushed for getting Flatpak and also portals from Git into OS, which is quite nice because then, like on the next day, I get an update on the computer, and if I broke anything, I will see it. And then there's the other thing that we currently have, which is like this, the versioning scheme of Flatpak and portals is a bit weird in that like the even numbers are stable releases and the uneven numbers are unstable releases. Everyone just kind of doesn't understand this, and I think that's the reason why a lot of distributions started shipping the unstable stuff. Yeah, not great. So I kind of want to get rid of this. Okay, so when it comes to maintainership, I said like most people, most of the maintainers, actually all the maintainers left the project. So I start basically being the person who's doing most of the reviews of PRs. I started doing all the triaging of issues and security issues, unfortunately, as well. There are some other people like BBHT. I can't pronounce the proper name, sorry. But he's been helping out a lot as well. He's doing great work on FlatUp and on Flatpak Builder. So that was really great. I nowadays have a bit of help from within Red Hat again, which is better than it used to be. We have a few people doing reviewing if necessary. So I think we are at the state again where we can accept contributions and they will go somewhere. So please send your pull requests. We can actually handle this now. But also Flatpak is in a bit of a situation where bigger changes are kind of yeah, we are stable. Let's put it this way. So if you want to do something big, you kind of have to talk with us first. So comparing like where we were last time, I think a lot of things are improved. I'm still not sure if it was fine, like what happened to Flatpak, where all maintainers left and basically we were in a really bad situation. I kind of wish that things didn't go that badly to some degree, but I guess at the end it worked out. But yeah, we still have constraints on how we develop Flatpak because it is stable, it is being used so actively, and because the code base is nowadays not that small and also not that easy. There's a lot of moving parts to everything. So most of the improvements we want to do and we can do are not really inside Flatpak, but in the ecosystem around it. So how we set up everything in the portals, like all of the stuff. So yeah, still viable, really. The code not just complex, it also is like not really prepared for a bunch of things that people want to do. Like the OCI support in Flatpak has been added in addition to the OS3 backend, and it was kind of the code paths. They didn't really abstract away like the entire storage backend or anything. They just added a bunch of different code paths to everything. So we are now having a bit of a every time we add kind of a storage backend, it becomes an absolute mess. So I'm not very happy about that. The abstractions are just not really there to make good changes nowadays. And the other part is that it's actually has been 15 years of Flatpak. Like it's been a long time. There's a lot of legacy stuff in there. There's a lot of like we can't break users' apps, so we are always backwards compatible. There's a lot of constraints here. We kind of want to change this, so there's a talk tomorrow. You should all come. I mean, you don't have much choice if you. Yeah. So let's see. What happened? One thing that happened last year is that we had a bit of an issue with license compliance. Some people noticed that we were not sharing the license files inside our applications. And there was a bit of an issue with that, and people were not extremely happy. So we had to kind of, in a short time, change a whole bunch of things inside Flatpak Builder, inside Buildstream, inside Flatpak Runtime, to basically get the license files into the builds. It also had to be backported to a whole bunch of existing runtimes that we didn't actually support anymore. And yeah, it was a bit of a mess, and a lot of people had to contribute to make this happen. We still have improvements to the stuff. but essentially there's a nice blog post about all of this that you can read on the FlatHub blog, and yeah, wasn't great, but we managed to do this, and now we're compliant, yay! Another feature that we shipped is pre-installing, which is like, so last year I was also talking about this, that it's essentially ready. Like the change is that we merged it, that Universal Glue and RHEL, they started adopting all of the stuff, and there were a few bugs that we had to fix, but overall, like, people are using this nowadays, and it seems to be working. So pre-installing essentially means that you ship your operating system, and then instead of having apps inside like in the image of the operating system or as packages in the operating system, you have the applications coming from Flatpak itself that you have in the core of the install. So yeah, RHEL is even using this in 10.2 to ship Firefox, so it's being actively used. There's also like some the pre-installation approach that we took is rather simple, and it has a lot of like constraints. Especially for like factory reset, we don't have a good solution. So I assume that in the future we will have to redesign this to some degree, but for now it enables a bunch of like distributions and operating systems to move over to Flatpak. So I think it's a win. What we also started to do is ship more OCI features. Like this was something that we supported for a few years now, but we are finally doing signatures. That was kind of a really big missing part here. Yeah, you just didn't check any signatures, whereas the OS3 stuff was all GPG checked. I mean, if you listen to Labs talk, like it's also not the best, but you know, better doing OS3 with GPT than not doing OCI without any planning, I guess. We started supporting extra data for the OCI code pass, which means that like you can, some Flatpak applications they don't ship with all the content. They have to download something from the internet because of mostly license reasons. So they at install time download something. For example, H.264 in Fedora was used like that, and yeah, that's support for it, so that it actually now on Fedora, if you use the Fedora Flatpaks, you actually get video playback, I guess. The same, also there's compression stuff now in there, which is helping a bit. Yeah, the pre-installing stuff actually works on OCI now, which also didn't work before, which was a bit weird, but we made it happen. And there's like authorization for the remotes. So when you pull from a Flatpak remote, you might have to authenticate. That worked for OS3 before, but usually for OCI you have different ways of authenticating against the remote, and we implemented some of them. So yeah, what else is new? I think this is one of the bigger like user-facing or rather application-facing changes that we did. And essentially, like what happened is that the ecosystem around Flatpak moved along, and some of the assumptions that we made in the permission system, that, for example, yeah, they just are not valid anymore, and so we need to evolve the permissions that we have, and that was a bit of a task. Like, for example, if you want to use a USB device, you need to specify device all in your manifest, and then you get access to like dev USB or whatever. And nowadays we have a portal for this, so you can use the portal to get access to some devices, and it's mediated, and the user has say over this. So you really should use a portal, but there are issues with this, because if you stop using the device all permission, then you might be shipping the application on some systems where the portal has not been updated to the version which supports the USB portal. So essentially, if you update your manifest and like tighten the permission, you would essentially break some applications, or rather break the application for some users on all systems. So now we have a new syntax for specifying conditional permissions. So you can essentially specify that you want to have device all permissions if the USB portal is not available on the system. unfortunately, this is like a runtime decision. Like you might switch from like, I don't know, one desktop environment to the other, and the one provides the portal, the USB portal API, and the other one doesn't. So yeah, this conditional system is kind of what we had to come up with to be backwards compatible. Yeah, so security was also a big thing with Flatpak, especially in the last 6 months, which is also the reason why I did not release a stable release this, like at the end of the year, like I want to. I think in Nome, I'm not entirely sure anymore, but there was a grant from which there was a security audit, which included Flatpak, portals, and a dbus proxy, and bubble wrap. So all the components, all the security relevant components of the entire Flatpak architecture that you need to run anything. They did find a bunch of issues. Some of them were rather easy to fix, like one patch and that's it. But there was also a sandbox escape, which is quite bad. And much worse really is that the sandbox escape was absolutely not easy to fix. Yeah, and in the portals we kind of had a very similar issue. And it essentially all the security issues that were found were essentially boiling down to path traversal issues. So essentially whenever you access a path and you open something based on a path, the file system might change under you, like the race conditions. So whenever you open a file on a path, you might get one file or another file and you won't notice it. So if the path is controlled by an attacker, you might open files that you did not intend to open. And that was the case for all those security issues. Both glib and what we're using in Flatpak, a library called libglnx, they both don't have had great answers to how to deal with this. For example, glib is like our GNOME standard library, and usually if you want to access a file, you pass a path into like G file, whatever, and then you do something with it. For example, if you want to trash a file, you would like write G file trash, and you pass in a path, and then the file gets trashed. But if there's an attacker who's controlling some part of the path, and it's running in the sandbox, it can point to some other file that is not in its control and screw everything up. So the APIs were really not helpful here, and we kind of had to invent our own stuff to make the file access work. So yeah, so we created something in libglnx to deal with the issue. It's kind of inspired by what systemd is doing. We are using this stuff now basically in all the projects where it's relevant. So after like 3-4 months, we released something. We released a fix for the issue, but unfortunately, it also broke applications. So not just a few unimportant ones, but Steam and Epiphany and basically all Chromium-based browsers, because they were using this weird site sandboxing thing. So it wasn't great. We had a week of like really horrible debugging and trying to unbreak all the applications. So you might have had issues with launching some of the applications in 1 week, so it was on me. So kind of what I learned from it is that we need more and better tests, but also that sometimes the tests that you kind of have are not really testing the things that applications are doing in practice. So manual tests are unfortunately still kind of a thing that you need to do, but it doesn't really scale, so yeah, the situation isn't great. There's a blog post about this, and it goes into much more detail. Another thing that is happening is that LLMs are getting kind of good at finding security issues. We are receiving like a bunch of security reports every week. Most of them are really bad, and LLMs don't really understand the security model of Flatpak. I think there are like use cases where it's more obvious to the LLMs how something works and where it works really well for the LLM to find the issues. But yeah, Flatpak is a bit yeah, it doesn't seem to be really understood by the LLMs, which means that mostly you get really bad bug reports or security issue reports. But unfortunately, it also finds a bunch of ones which are real issues. So that's something I had to deal with a lot, and I assume that it's also going to continue. But the upside of all of this is that it should mean that our code quality improves and that we should get more secure here. Yep.
Did you consider like writing some documentation for like testing by the LLMs to minimize the slope, security vulnerability, like posts, and just like hope to get just better issues from that?
Yeah, I mean, I think an issue is that we just didn't document the security architecture in general anywhere. Like, I don't think it needs to be specific to like LLMs here. Like, the issue is mostly that we do not document any of the assumptions that we make. So like the LLM also won't find any documentation. So yeah, I think it's something we should do at this point because it's useful not just to LLMs, it's useful to everyone. But yeah, I don't know. Probably should do something about this. Yeah. Okay, so let's see. There are a few more things that we did, which didn't lead to code being merged, but we are kind of experimenting a bit with like how we want to do GPU drivers in the future. This has been a pain point, especially with NVIDIA. One of the good things that are happening currently, which is completely not like from our side, is that NVIDIA, it seems like there's going to be like proper open source NVIDIA drivers in the future, which would make the pain like much less. But there are also other approaches that we have been looking at to kind of make fallback at least easier, which is using essentially virtualization technology to run GPU acceleration. It's essentially a socket that you're using to talk to the driver on the host system, and it's basically what VMs are using nowadays to do this. So we have been looking into this, and it looks promising as a fallback for all the cases where the primary approach doesn't work. There's also we've also been looking into trying to get rid of X11 completely from the runtime. For example, GnomeOS has no more X11 in the base system at all. So good stuff, but our runtime still do. So we are kind of looking into getting the X11 bits out of it, putting it in an extension, and then also wanting to not rely on the X-Valent implementation that is connected directly to the compositor and use something like X-Valent Satellite so that it's completely isolated from all the other applications. So there are things that we want to do, and I think they should improve security for all the few applications which are remaining on X11. Okay, so moving on a bit to from Flatpak and more in the direction of portals. We had also a few stable releases in the last year or so, but basically same story as with Flatpak. People didn't really feel responsible for doing releases anymore, or in general maintaining this too much. So at some point I also decided to do unstable releases for portals. This year already 3 of them. But yeah, essentially the same story here. I want to do a stable release, but it also was essentially held up for the same reasons that the Flatpak one has been held up. We also have the stable unstable split that is kind of annoying with with the versioning scheme, which is completely misunderstood. I think Fedora is shipping the unstable version even, so I don't. It's a complete mess. Like, we should just get rid of this. But yeah, at least we do have updates again, and hopefully soon a stable release. On the port side, we're actually a bit better off currently than on Flatpak, to be honest. We started kind of having a more formalized approach to how we do maintenance and this kind of stuff. So for example, we documented that we are only changing the interfaces of the portals if Norman and KDE agree to do the changes. It has essentially been this way before. We just formalized this and put this into a document somewhere. Another thing that was kind of annoying and has been a bit better now is that the portals support different kind of sandboxing technologies like Flatpak Snap. And sometimes it was a bit hard to get the people from other sandboxing technologies to actually take care of their part. It's becoming a bit better again. We also are trying to kind of have a process where specific portals are being helped out by, I don't know, like specialists in the area of the portal, because it turns out that like portals are essentially APIs for everything, and like whoever is working, like I'm maintaining this stuff, but it doesn't mean that I am an expert on all the different portals. Like Till here is, for example, now helping out a bit with like helping out a bit with the printing side, so I appreciate that. And we kind of want to have this system more because we are working on new portals where this is becoming even more relevant. Unfortunately, like as much as we do have people working on this and we do have people reviewing stuff, like review capacity is always kind of limited, especially for like bigger changes that we want to do. It's a bit of a pain, but it's working. Like we are getting somewhere. Yeah, last year I also had talk about how we are testing portals, and yeah, that one was actually it wasn't merged at this time, and then we merged it. So I'm just kind of telling you that yay, it was merged, and also it was really useful. We have pretty good integration testing now. A lot of features that we are adding, like people are adding tests for it without me having to like remind them that they are tests. So that's really nice. It seems to have helped to prevent regressions. Like I can't tell for sure because like you never know if it would have happened with or without it. But what it definitely prevented a lot is a lot of memory leaks. Like all the integration tests are running with async and whitegrind, so it's actually exercising the entire, it's helping to exercise the static analysis here. And essentially, like the reason why I was doing all of this is because I want to make more and bigger changes without having to fear of breaking everything, because if the portal stops working, usually a whole bunch of applications stop working as well. So yeah, there were a bunch of new things this year. It's not a lot, but one thing that is really user visible is probably that if you were on a file system like Btrfs, the document portal would forget which files you were giving access to apps. So you reboot and suddenly, like, I don't know, your password manager forgot where your password file is. So if you were running into that issue, that has been fixed. For input capture, we have like clipboard support. So if you like use one of the fancy remoting tools, the clipboard stuff should work better now. Session persistence means essentially that instead of having to go through a dialog every time, that it will remember the settings, like the things that you chose, and the next session it will just restore everything, and the user doesn't have to click through dialogs again. We have reduced motion settings. It's a feature that the desktop environments and like the applications have to implement, or the toolkits rather. But yeah, that's always quite nice to have more cross-desktop things that, like settings that we all agree on and can get implemented. Also, the prompting for screenshot apps has become a bit better, like less dialogues, less annoyances. We added support for linapps, which is like attendees sandboxing technology, and with the changes in like maintenance, they are taking care of the code now, and if they're not, it's getting moved. So I think it's like the right way to do this. And there's a whole bunch of bug fixes and like improvements to a whole bunch of portals that you will probably only notice if you are actually like poking at the portals as an app developer or something, or as a desktop integrator. We've also been moving the entire portals, or I have been moving the entire portals from like a model where threading and async, essentially what's currently going on in Borders is that we are using a lot of threads because a lot of things are async, and async is quite annoying. You either have a bunch of callbacks and like have to push stuff into structures and pass them around, or you use threads and then like if there are a lot of requests going on concurrently, you have like hundreds of threads if things are kind of going badly. So we are moving towards a system of fibers and futures, and it should essentially make it much easier to create the portals, and it also just essentially reduce complexity by a shit ton. And the code is ready essentially, and after the stable release I want to merge all of that and then rewrite all the portals like one by one to use this kind of new system. And it should also hopefully make it easier to add new portals without having to like, yeah, do threads and locking and all of this stupid stuff that usually goes wrong. So yeah, we went from like this year we got a bunch of things done. I would say like, especially from a government's perspective, we are much better off. Like, you can actually send code, you can open PRs, we can implement features. We have been doing so for some of them. Unfortunately, the security stuff has been a bit of a, like, making things slower than it should have been. The resources that we currently have are also, in my opinion, just unfortunately still not where they should be. I really hope that some people decide to join the project. Like, you can do this nowadays. Like, there are people who will review your code and will try to get things upstream. There's a lot of different things that we want to do. So yeah, if you're interested in any of the things that are on the right side here, like it's not a small list, but if you're interested in any of that stuff, please do help out. If you're an app developer, let us know what is missing here, because essentially for portals to work well, we have to know what applications want to do. Yeah, and a lot of this stuff we want to do for Flatpak 1, but also we have a lot of things we want to do with a completely rewrite with Flatpak, and I'm going to talk about this tomorrow. But other things that are on the right side, or most of the things which are here on the slide, are things that we kind of need no matter what. So I think, yeah, a lot of things to do. And I think that's essentially it. And I'm open for questions. Yes?
About the graphical drivers thing. So
Yep.
something common is like the host drivers update, and then if you forget to run a Flatpak update, you talked about that a little bit. Does that problem go away?
So that problem only exists essentially if you're on a proprietary driver.
Sure.
Which is kind of my point here. Like, we need to update it because the kernel and the user space are tied together, and then like you essentially have to download the new driver, and if you don't do that, then it just doesn't work. And whereas like the open source drivers work the way where the user space work on all the kernel versions, therefore like it doesn't really matter. Whatever we ship in the sandbox will run on whatever kernel. You can update your operating system and the kernel, and it will continue working, right? So that is kind of the good model to have. We just ship the drivers in the runtime, they just work, you update and nothing breaks. So that is how things should work. Unfortunately, it is not how they do work with NVIDIA, and therefore things are kind of bad there. And I think the open source drivers will help a lot. I think they're happening, but unfortunately, like they will only be happening for like pretty new GPUs. So it's unfortunately going away entirely. But I think this fallback system that we kind of want to have, where it's using virtualization to use the host driver, that should at least mean that you don't have to download the new thing, and it will still run even with GPU acceleration. And then whenever you can update like the Flatpak thing, the drivers in the Flatpak, it should use the latest stuff again. Yep.
I do have a lot of meetings over the day, and I'm screen sharing constantly, basically, and I'm constantly getting annoyed at those screen share pop-ups, hey, select a window, whatever. And I was recently thinking, hey, maybe I should just patch the desktop portal to always share this one window, which I'm always sharing. And my question is kind of, does the desktop portal already have config flags? And would this be an interesting extension to the desktop portal which you would accept upstream? Like adding a config flag, for example, saying, hey, always share the window with window ID X. You can also say no. That's still fun.
Can we make the dialogue suck way less though?
So, the design team here, if anyone signs up for implementing it, we'll make a better design.
Yeah, I mean, yeah, those are hard questions. Like, because the flows are the way they are for a reason mostly. Like, yes, you can implement something like that, but it won't be useful for, I think, no one else here probably. So it would be nice to make the permission system a bit more, you know, like, to make it easier for people to like customize things if they wanted to. To some degree, we kind of have this already with some of the portals, and like session persistence is kind of helping with stuff like that. So usually we want to take the approach where like it's helpful for all users, and session persistence is like the thing that is trying to get away from having to like, you know, press all the buttons again. But yeah, I don't know, like it would require like kind of having a more configurable kind of end user accessible setting system that you might be able to do, but I don't think that there is a lot of like interest in doing this because it would make things way more complicated and a lot of changes, so I'm unsure.
Thank you.
From the design side, I'd be very interested in the specific flows that you're...
Sure, let's talk later.
Couldn't this be solved entirely by the desktop just having a button on the prompt of use last choice? With the, like, that feels like that would solve it. But that would be on the desktop side, right?
Usually, like a lot of those things are kind of design issues, right? Because you have to figure out what you actually want to do, how would you implement, like what's the flow, like what users expect, what can you do without like making it a security issue. Like the security issue thing is like often a big part of like why things are the way they are. But yeah, there's probably a lot of ways to improve things, but they often need to be thought through very thoroughly. So I don't want to make any kind of yes or no statement about this kind of stuff here.
Or like still on the like screen recording portal. I don't know if it's already featured, but seeing it from current implementations, I don't see it there. Is there a way for application to choose specific window that it wants to screen record and just ask for that, like window or the screen?
So generally, we try to avoid like exposing any kind of window identifiers, screen identifiers, and all of that stuff to the application itself. And that is the reason why you have to select it in that system. It's also kind of an issue because like, even if you have the identifiers, like how does the user know what it is? Usually, like in the UI, you don't get like a list which says window Firefox, window 1 or whatever that you want to show a preview of the thing that you want to share. So if you want to put this into the client, then they already got access to it, and like it's all moved again. Like
I mean, yeah, I have a specific experience from WLX overlay. You know, the application it like screen records the desktop and puts it into the VR. And the problem is that it asks for specific windows when like starting to screen share. It knows like what screens it wants to screen share, but it cannot choose them. It asks for a specific screen.
Yeah, but like if it knows about the specific windows, it already has like kind of an escape hatch. Like it shouldn't be able to get specific window handles in the first place if it's properly sandboxed. Like Wayland doesn't give you the information, the portals don't give you the information, so it gets them from somewhere else.
It's not for that application.
Yeah, there you go.
But it uses the portal to screen record. And,
yeah.
Like that is very limiting.
But essentially, if it's a Flatpak application, it can always be escape hatches where you just like, where we could say, okay, if it's a host application and you set a certain flags, then like none of the security stuff is relevant. Like, there are ways we could make like nicer to use for applications which are not sandboxed, I guess.
Okay.
Thank you.
Thank you, Sebastian. Well, yeah, we can just join this. Cool. So, thank you everyone for staying with us up until now. We are going to have a small break. Well, it's not very small, it's like an hour and probably a bit longer. But before we have the break, we are going to have our group photo, which we are very excited about. Start fixing your hair, get ready. We are going to stay, well, on the podium. Some people can just stay in the lower part of the stage. People with the red lanyards, if you'd like to join, just please go and grab an orange lanyard, and just, if you want to be part of the group picture, feel free to do so, we'll be happy. Otherwise, yeah, please just don't join, because it's going to be posted on social media, and yeah, if you don't want to be there, absolutely not a problem. So yeah, group photo everyone, and then we can go and have the lunch. Everyone can just come here. Also, when we come back from the lunch break, a quick note for everyone holding a red lanyard. If you wouldn't mind to sit on the right part of the, like on that part, on your left side of the chairs, it's going to be very helpful, so we can take some pictures of the rest of the public, so we can share them with everyone.
Have other hands.
So
Before I start, I actually have an organ point, which is that I would like to file a formal complaint about the fact that you have to pay with credit card for the drinks. I think that is, I don't know, just like, we're in Berlin here, come on, this shit should be illegal. Like, anyway. Side
Get a credit card.
But no, let's ban credit cards instead, much better. Look, legal tender, okay?
2026, man.
No, 2027 is the year of no credit cards. Anyway, hi, I'm Tobias. You might know me from work on GNOME design and related things. And today I'm here to talk about Local First, and in particular some of the work that me and some other people from various communities did. But I'm the only one here at conference, so I'm the one presenting it. But yeah, so I'm going to be presenting the design perspective. It would have been better if someone from the technical side were here also, but such is life. And but I think in order to sort of like get to a specific project, it makes sense to start several steps earlier, and that is with this image. Because I think like I don't know if any of you noticed, but I think the vibe has shifted in the last 2 years with regard to like how people feel about technology and like you know how secure they feel with regard to what the US is gonna do in the next 6 weeks to months. And I think that does change a lot of things, right? I think in 2025 everyone sort of realized, oh fuck, we're fully dependent on the Americans and they might like do whatever tomorrow. And I think from a free software perspective, where like for the last, I don't know how many decades, we've been like, yeah, maybe like technology should not be dependent on a few small, like whatever, on a small group of like billionaires in the US. And you know, like this is all stuff that we've always been saying. And for the first time in a while, it feels like there's maybe like an opening for other people to listen. I think, unfortunately, from a sort of free software movement perspective, we've not really like met this moment, because a lot of the stuff that people are like, oh yeah, we really like what this, and I think like some of the specific things are like specifically the kind of things that like some of the people in this room have been wanting to do for a long time, and so I think there's like sort of this interesting synergy, because like a lot of people are like, oh, we want phone, but we don't want Apple or Google. Well, there's not really anything daily drivable at the moment, right? Like there's various de-Googled Android things, but that's not Google free. There's all kinds of weird, like sort of hybrid things with like hybrids and so on that like can work, but like everyone knows how unsustainable that is. And then you have like post-Marquez Linux mobile stuff that is very early stage, whatever, experimental things that like even the developers often don't daily drive. It would have been great to like have a solution right now, but we don't. And I think the same goes for a bunch of other stuff, right? Like on the security level, the stuff that Lana talked about this morning, that stuff that we should have had 2 years ago, but yeah, now we're doing it now. And I think there's a bunch of other stuff. And I think in particular around sync and so on, there's a lot of like just areas where we fully have nothing. Like we have no like good, whatever, just sync my stuff APIs on our platforms, and every other platform does that. And I think in general, like we have a lot of sort of 80% solution where it's like, well, OpenStreetMap is kind of like Google Maps, except it doesn't have an app, and the apps that do exist, they don't do good routing. And also, if you want a restaurant, well, good luck. And we have this stuff for a bunch of different areas, and the things are nice if you're like really key and like are into the community side of it and so on, but it doesn't actually solve the full problem for the broader public, which is sort of the thing that would have been called for in this moment. And I think that's just at a high level a problem. And so my sort of general position and that of some people in our community is that maybe we should be more strategic, more focused, do fewer things, but like actually solve the problem 100%. Instead of having like 4 80% implementations that all don't actually solve the problem. But I think also, given this context, we need to be building for a much more scary and uncertain world than we ever had before. And I think also in our community, there are a lot of assumptions around like security and sort of trust and things where we're like, well, it's fine, just like, you know, it's kind of always worked this way, and like, whatever, this is a server here run by these people, we can kind of sure that like, that guy's not gonna get hacked, right? And that, like, maybe we should get a lot more paranoid in everywhere. And sort of out of all these ideas in the local Berlin community and some of the people around it comes a new structure, which we call Moda Collective, which is sort of people from all these areas that were working on various problems of this sort for years anyway. I sort of said like, well, maybe we need to organize more to actually get some of these 80% things to 100, or like focus more strategically in some of these areas. And for us, that starts with the like sort of thing we're trying to do. I think free software is still a useful concept and is an important part of what we're doing, but we need to be doing more than that. I think in the GNOME project that was always understood, right? Like it was always, okay, software freedom, but in a way that works for people who are not technical. But I think nowadays we need more than that. We also need to be way better at security. Like all the stuff that Leonard did, that's good. Table stakes sort of nowadays because Android and iOS all do it. You need to think about like scenarios with the internet way more because that's happening more and it's gonna be happening more. I think there's like a whole bunch of topics around sort of this idea of, okay, well, with these 4 freedoms that you need to be taken into consideration if you actually want to solve problems for people outside of this community. And for the model side, this translates into a few specific goals. One of them is all this security stuff that I'm not going to go into technical detail because it's not my area, but insert Leonard talk here and some other things. We want a phone that you can actually use instead of Android. We want to look for sync. We'll get into that in more detail later. Yeah, image-based, sort of also general part of the security story, but also robustness and so on. You want hardware longevity because supply chains are, and you want to be sure that the computer that you have is going to continue working, and that old computers are going to continue to be viable. And all of that doesn't work without an app ecosystem, which is why we're all here. We want a ecosystem of good emancipatory apps for people to use on those devices and systems. And from a model side, like we look at this from a very high level point of view. A lot of us are developers and designers, so that's stuff we do, but we also think there's like a lack of organizing and like focus on sort of strategic grants kind of things to like be like, okay, this is an area where like a lot of people are motivated, but no one has time. Let's maybe organize some grants. Maybe the problem is actually policy. I think on the phone side, a lot of stuff is like this, right? A lot of phones have locked bootloaders. There's not really a technical solution there. You kind of need to outlaw bootloader locking, otherwise. And so there are a bunch of policy questions that I think, as sort of technologists, also talking to sort of policymakers, you realize they just don't know like what exactly the technical moving parts are. And if you explain to them, there is actually a lot of openness to this, and it fits into existing frameworks on repairability and like whatever Digital Market Act. Don't know the details, but like so. Something we realized is that this is an area that we should probably be more involved in if you actually want to solve this problem long term. And I think from the model side, our long-term goal is like we want something that sort of we call tongue-in-cheek the free software iPhone. In that the people who are currently using an iPhone would be willing to use this. And the reason why I think it's a good overall frame for it is because it basically encompasses every other thing we do. Like within this is also a good free software laptop. That's essentially a subset. It's like all the sort of sync sorts of things that you need. It's all of the UX stuff. It's just sort of a complete package actually replaces an iPhone. And for this, we have a very specific technical stack that we think is most suited to do this. All the standard Linux SysMD for desktop stuff, GNOME Desktop, GTK and WIDA, like app platform stuff. Beetle Panda, we're going to get to that in a little bit for local sync, and Flatpak for app delivery. Generally, the way we do this is just we work upstream in all these various projects. It's not like some fancy new project somewhere. It's just like we look at where are the things that are missing, and then we work on them in these projects. And specifically for today, there are a bunch of things in various areas that we're doing. I think the specific thing I want to talk about today is the multi-device sync part of this. Because I think for the last 15 years or so, like whenever in the GNOME context we were talking about sync, there was always this problem like, well, yeah, but we can't really host a server. And so then you're like, who's going to be hosting the server? Like, the finance of it just like doesn't really make sense because with every new user you need to pay money and then you need to like get money from them and then everything gets really dicey. But over the last 10 years, there's also been some interesting advances in like just like literal computer science. All this CRDT stuff, various things around peer-to-peer networking and so on have gotten way better. And with local first, the idea is that instead of like having a cloud where all your stuff is and you just kind of rent it from them, your data is always available offline. When there's network, you can still collaborate, but it's always an optional thing, and it never breaks. You always own your data, and like if today, like you only have your device from now on until forever, you don't lose anything. You can always use that. And I think that really like sort of opens a lot of new possibilities because you're not dependent on like having a big company and a lot of money in order to provide these collaboration features that kind of everyone expects now. And so there's the question like, can we have sort of competitive indie free software apps that have good collaboration and sync features. And for that, I think a good sort of benchmark is like what do other platforms provide, right? Like what does the iCloud Sync API give you sort of as an app developer at a really high level? And I think it's basically these things. You want somewhere you want like sort of always available sync infrastructure that you don't pay for by usage, right? Because otherwise per user ends up costing money, and then you charge money, you need a sort of account and identity system, right? Like somehow you need to be able to share with other people. You need to like know which devices are my devices, how do they find each other, stuff like that. And then, I mean, I actually don't know about the iOS part. One something we want obviously is this needs to work offline. So like we've in the I don't know broader modal community we've been talking about this for 4 years or so, and I think we've like had various architecture discussions. And I think at some point we sort of like settled on this roadmap in collaboration with the people and others that kind of goes like this. You start with a prototype because that's something you can easily ship, right? You have an app that is fully self-contained. You can ship that by Flatpak and it just does stuff. And you don't have so many other dependencies, you can easily change stuff. As part of that, building one app means you need to figure out a lot of the fundamental questions around like what is the UX, like what are the developer APIs that make sense and so on. You do some real life user testing with that, you learn from that, you iterate and so on. You prototype what it would look like to integrate this into the system so that every app doesn't have to do all of this. Eventually you ship a stable app and like you finalize the APIs. All of those much easier said than done, but like so this is kind of like how we're thinking about this. And in the end, great look first app ecosystem. And sort of this first step for us is this app that we've been building over the past year and a half, which is Reflection, which is a Notes app, just basically a simple GTK Notes app where you can collaboratively type in a text view. UI-wise, it's nothing fancy. Under the hood, a lot of very fancy peer-to-peer stuff. Sort of for context, we started this, I think, in December of 2024. Not that much happened until like a prototype fund started middle of last year, and then we've had 9 months or so of funding for this. This is kind of where we're at right now. The networking and collaboration stuff, which we thought in the beginning already worked, turned out to need more work. But now it does mostly work, although the other day we did find some new bugs that we were confused by. But sort of that side kind of works. It's on Flatpak beta because we're not committing yet to like being able to always sort of update to new versions and all your data will be able to be ported without like resetting stuff. And we also have experimental microbuilds. But like the app itself is sort of I tested that for all these APIs, and as the stack matures, we're hoping like we'll then also ship a stable version of it. And yeah, of that I can give you a very quick demo if Swick and Adrian are online. Let's see. So this is the app. It's literally GTK text view. You can zoom it and type here. Hello, it's text. I can select something and they can see it, or if they select something, I can see it. Hey, selection. And so we don't have an identity system yet for reasons that I'm going to talk about, other than these pseudonymous things that are just like, basically it generates a color and animal based on your public key. And you can go offline and then you don't get any updates. And then they're typing. Also, I am typing. Then I can go back online. And then it's merging everything because the CRDT is magic. I don't know. Various computer science wonders are happening here under the hood. Makes it nothing. And the way it works right now is like we have this very long share code that you basically need a side channel to share. But like there are trade-offs with doing an easier version of this, obviously, right? Because then you have collisions and so on. So like for now we're basically doing the simplest version of all the pieces in order to like test the technology, and if we want to improve each of the many areas, and that's where we're going to get to over time, both like on the design and on the technical side, because a lot of these things are just like fully not solved. And this is like a list of documents. If you go back, you get that. Yeah, and so this, I think the work on the front end, mostly Julian Schwaber, as part of this prototype fund thing, and then the Peter Panda team, Andreas, Sam, and Cliff, been working on this for the past year. And the second thing we did as part of that is G-object bindings for Peter Panda, because it's a Rust library, which if you don't use Rust, not so easy to use. And so we made G-object bindings, so now you can make pretty easily Python and TGS, and whatever, Vala, and whatever your favorite languages, apps. And with a few dozen lines of code, you can get sync between devices, and that all just kind of works. If you have any ideas of things that you would like to build with sync, we'd be very interested to hear from you, hear feedback about the API, like what you would have to see improved and so on. One thing we tried this week with Adrian and Swick and co is we built a tic-tac-toe app. It's kind of hard to see, the X is very small, but it's a collaborative tic-tac-toe thing on the local network. That worked surprisingly well, and it took what, an hour or so. Fully from scratch in the builder like new app template. So that's kind of like what you can expect right now if you play with this. But really, when I talk about here, I don't actually know how much time I have. I guess not that much. But then, is anyone checking time? Is anyone from the org? Is this being streamed? We don't know. Okay, well, whatever. Is a user interface research, and because I think like you think about like, oh, okay, well, whatever, we're doing the same thing, we're doing with a server, but now with no server. Well, it turns out everything's much more complicated. Because if you have a single server, then a lot of things are kind of easy. Like it does authentication, it like resolves conflicts, it knows the ordering and all this stuff. If every peer becomes sort of its own server, you all need to kind of like not step on each other's toes too much, and that's why you need all this fancy CRDT stuff. But basically, this is the way you think about it. Like everything a server would do has to be done by the clients independently. And so I'm just going to go through some questions and kind of like how we either solve them or are thinking about solving them. The sort of obvious one is like in a peer-to-peer system, what if no one's online, right? Like I wrote a nice notes for my meeting. We were all like together online, but then the one colleague was not online. Now no one is online, and they come back online. They can't see the notes. Not what you want. And so generally what every sort of peer-to-peer local first system comes to is this kind of architecture where like in the cloud, okay, you have a single unencrypted database, it's somewhere in the server, everyone fetches from there. What we call support nodes and others have other complicated names for is basically like a server, but it doesn't have like a full unencrypted database, it only gets some encrypted chunks that basically the peers store there for like others to pick up. And then like when I'm no longer online, like the people who then later come online, a colleague who wants to read the meeting notes and pick up the changed file from the support node, but it's fully encrypted, there's no metadata. And also, right, you can have more than one, you're not locked into a single provider. Actually, this is all on this slide. And also this is feasible to self-host because it's not like whether with a cloud server, okay, fuck, this is offline, no one can use anything. Everyone needs to have a pager in their pocket, otherwise, whatever, we need to promise uptime. If for some reason, like, the server is offline, you can't sync right now, but all your stuff still works. And then if in the morning you restart a Raspberry Pi, you know, like there's a much more tolerant sort of, whatever. It's much more tolerant to smaller issues on the info side. And this is some UI stuff we tried for this. The idea was like maybe this kind of works like a VPN, where like you buy a MoBot token for whatever 2 months, and then like someone hosts the server for you for a certain amount of time. You connect it in the support nodes UI, and then when it expires, you just connect a different one, or maybe you have multiple or stuff like this. And there are a lot of open questions around this, like how do you do this? Like do you do this sort of per gigabyte, or like is there an expiry date for stuff? Like how much sort of storage do you get to use on these support nodes? And this is stuff the Peter Panda people are actively working on right now, sort of figuring out an initial version of this. But essentially it's like servers without service in this like more resilient multi-party way. Second question, something we found a lot in user research is people are like, how do I log in? And sort of, right, it doesn't make sense here, you're already logged in. But from a user point of view, it's like, yeah, right, because that's your identity. And so then you get into the question of distributed identity, which turns out is very complicated. Because if you're on like a social media platform or something, then like someone is the arbiter of your identity. In a fully peer-to-peer context, no one is the arbiter. You can just give yourself any name, you can impersonate anyone, and that's a problem. So the classic solution people come up with is basically client-side address books, where on your computer you store a name for everyone, and so therefore no one can impersonate anyone if the names don't come from them, right? The problem is how you scale that in really large groups, and no one like really has good solutions for that. But I think like there's going to be a lot of research about this there is already, and there's going to be more research on this in the medium term future because everyone needs this. And like for example, something we tried is basically you do a verification flow with the QR code, and then you just like type in a name and give an avatar. We also tried some other ones where like maybe some stuff comes from the other person, but then you combine it with some client-side factors. So that, like essentially they can't fully impersonate because they don't control the entire identity, but maybe they control the image. But I don't know. There's some really complicated threat modeling questions around there that yeah, not easy to solve. But then essentially you would have some kind of contacts app that sort of has your peer-to-peer contacts, and you see which groups they're in, or like which documents you're sharing with them, and so on. Another interesting question that we didn't quite expect to come in this way, but like it makes sense. We were talking about like, okay, how do I like whatever add this thing to my RSS app? And it's like, yeah, when I sync with 3 different computers that have this RSS app, what we have now works great, except what it doesn't allow yet is revoking access from a device, because everyone shares this long code, right? And if you have the long code, you have access to the network, right? And so if you wanted to remove the device, you would basically have to send a second code to everyone by the side channel, which is not great UX, obviously. So what you actually need is real access controls, which P2Pan has a version of, like, at the moment, but like it's not fully stable yet, and like there are a lot of moving pieces to actually get this to fully be production ready. But the way it essentially will or does work is that every user is actually a group of devices, so all your devices are sort of part of this inner group, and then a document is just a group of users. So like if you share a document with another user, all of their devices are basically added automatically in this nested way. And actually an interesting question with this stuff is how do you do the join requests? So like if you want to do this access control stuff, just having the secret itself is no longer enough, but you still need to access somehow the other peers. And essentially someone needs to be always online in this joint network, and maybe like the admins, because they're the people who need to sort of approve the request anyway. Essentially you need a second network just for people to join the real network, the document. So there's a lot of like unexpected questions that from the design side you're like, wait, what now? But so from a technical side, oh yeah, right, somehow this information needs to get from from A to B. Another sort of, maybe sort of from the technical side, you're like, didn't expect this, but from a user side, makes perfect sense. No one's really like sure what happens when you come back online and take some changes and automate some changes. Because like, from a technical side, you're like, okay, CRDT, solve all this automatically, whatever, shouldn't be any conflict. But that doesn't really register with people, and there's a lot of uncertainty around it. And so, I think probably what you want is you don't want this automatic merging in all cases. You want it in cases where you're like almost real time or like there's not so much happening. But when there's larger diffs or like you've been offline for a long time, probably you want some manual merging thing so that at least like you know what you're doing there. So like if someone deleted half the document and you added a bunch of paragraphs inside it, you at least get warning before, and it doesn't just like merge something that technically makes sense, but in terms of the document, how you think about it doesn't really make sense. And I think also something that ties in with this is that sometimes you don't want collaboration. Even if you have internet, right? You just want to like work on your own brand for a little while and then see how it fits with everyone else, especially when a lot of people are editing at the same time. And I think there's this idea of like creative privacy that's really relevant there. And so ideally, like all of this would work together as sort of a built-in branching workflow, like you could see diffs and so on. But yeah, on the UX side, that gets pretty complicated. We've sort of experimented with some of it, but implementing this is probably a whole other like 2-year research project. But sort of, this is like sort of an idea where like you see the current version on the one side, and then you see all the versions on the other side, and it's like list them against each other. How you would do any of this for non-plain text is another great research question that I don't know if there's any relevant art for. But yeah, all of this is very interesting sort of research stuff. Another one that came up a lot is on the reflection team, we don't just have one document. We have one for our meeting notes, we have one for our sort of roadmap planning, and then occasionally a thing comes up where we need to write a blog post or something like that together. And so we actually share like not one document, but maybe like 10 or something. But right now, every document is its own network. Every document is like its own join code, which means you need to do a lot of sending join codes, which sucks. If you want to quickly just like with the same people share a new document, you can't really do that. And so what we were thinking about is maybe move the network to a higher level. It's basically like you share a folder, and then anything you create inside the folder is just like inside that, and it shares the same access. Obviously with access controls, all of this is going to get more complicated. You might want to like have a folder, but not everyone from the group has access to the folder, and then everything gets a bit more difficult. But I think this is sort of like something that we'll probably want to do with spaces. What else? Oh yeah. Files. Everyone loves files. That's also something that came up in sort of research and just like talking to people. People don't trust the database. Right now, this stuff is stored in an SQLite database. It's a file somewhere in a, whatever Flatpak app directory, and who knows what can read this later or something. People like having a folder with Markdown files specifically for this kind of thing. And it is really cool, right? From a resilient point of view, you just can back it up. You can do whatever you want with it, open it with another editor and so on. But conceptually, it's not trivial. What if you edit something in the other app while this is open and it's syncing and so on? We think we have a solution, but we haven't tried it yet, so asterisk. The rough idea is that like the app obviously has its database managed with CRDT and so on. That's the canonical version, but like every few seconds, minutes, hours, whatever, it materializes that into a Markdown folder. And then when you edit stuff in Markdown folder, it does also read that and then basically register those as changes in the app. We need to see how this all works exactly, especially with access controls, because maybe you have a file there, but actually you don't have permission to edit it. You have a read-only Markdown file, but the file system obviously doesn't know about this. Like, that's all metadata stuff in the app. So, but we feel like this could probably work, and maybe not even be that hard. Another fun one, deleting stuff. When you delete stuff on the server, well, it's gone. When you delete stuff on your computer, why did you delete it? If you delete it because the cops are at the door and you and your dangerous anarchist cell are about to be raided, maybe you want everyone else to also delete it, but also you wanted to delete it on your computer right away. And so, like, how long do you wait? Like, what do you delete? Like, there are a lot of sort of questions. And I think we haven't gone super deep into this, but like just what little we explored from the UX side, like immediately 15 different dialogues depending on the state of who has downloaded it, like who was last online, and so on. Maybe what you want to do is allow people to choose the trade-offs, where it like gives you multiple cases, but how to present this and like how to threat model it, and also depending on various of the other things is a bit tricky. And yeah, this is like just one example of like a weird delete dialog where like delete it right away, or like more options for deleting it on other devices, and then probably would show another dialog with like. Also to be seen like what kind of apps need this for what kind of use cases. But yeah, with all this stuff, like the threat modeling gets harder because yeah, you don't have a single place where stuff is. You need to think about stuff that might be offline for 6 months, or maybe some peers you don't know about because they like whatever were added and like are in a fully like whatever net split branch somewhere that is only online while you're not online. Right. So I think one thing that's interesting, in general, like a lot of stuff here is still experimental and will need more work. But one thing that's interesting, I think, for this audience in particular, is what can you do with all the stuff that already 100% works? And for that, I like sort of came up with this concept based on what reflection is today, and like just fully what works now. What could we do just by moving on some UI stuff, or like make some small changes? And I think for the support nodes, I think an obvious one that people already came up with by themselves from our community is just leave the laptop open with the document open while you have a support node. I mean, it's not an encrypted support node or whatever, but like it does the job of syncing for everyone else. If we just have a headless mode and run it on a Raspberry Pi, that's kind of solved, and it would be easy to do. The spaces thing you can approximate by just having like essentially multiple documents in a single network. Not sure how deletion would work, but other than that, I think it just works. Exporting to folder, I think, is just also a matter of trying it. I don't think it would get hard. And then also this contact thing, just like assigning names locally to the contacts you have, even without like whatever cross-signing QR code flow, maybe would already be an improvement in terms of like usability, at least for like non-security relevant use cases. So those are some ideas. This is what it could look like. Maybe it would have a sidebar with documents and like basically a switch here for the different spaces. Those would now be the network, and then the peers per network on the other side. One of them could be the Raspberry Pi. And yeah, this could be like the contacts app that you get with this, where you can just like manually edit each of your contacts. Some takeaways. It's early days for all of this, I think, as you can see. But can build some workable prototypes for some use cases. I think reflection, a bunch of people use it for specific things already. And I think as a community, there are probably a lot more interesting things that we can come up with. Also, the P2Panda stuff is moving pretty fast. So maybe by the time you've started building your prototype, access controls will work or something, right? Like, there are a lot of moving parts here. But yeah, I think it's in general like a fun and exciting space at the moment. Also, the one thing we found is that a lot of people are like, well, this doesn't seem quite stable enough yet, so I'm gonna wait. And then like their specific thing like doesn't really get any testing, and then it just like doesn't really improve because no one's testing it. So I think that's maybe a fallacy that we're trying to get out of. Also by like encouraging more people to get their feet wet and try it, because this is a great time to prototype. We have the object bindings. I don't know. Think about like what you need that syncs. Some ideas. Obviously, the reflection X mockups. If you know Rust or GTK and want to like give it a try, there's like 15 small things that you can probably do in a few hours. Games are a fun one. We did the tic-tac-toe thing this week, but maybe someone could build chess. Maybe like an actual app integration in like an RSS app or a podcast app, right, where you want to sync your feeds. It's a bit early for that, but I think an experimental one that like knows that there are some limitations we can't ship it yet could actually be quite cool, just like for knowing what the moving parts are. And in general, like the P2P people have a lot of work on their hands, and there's not so many of them. If you are interested in Rust and distributed system stuff, it's a cool space to hang out. Some places to do that, some links to the Reflection GitHub. We have a Matrix channel, not used that much, but we do monitor it. And yeah, Mastodon links for both Model and Peter Panda. And that, if you have any questions, I'm here. Thanks. I don't know if we have time for questions. Is there? Okay. Perfect. Easy. Yeah.
One of the things that you said, anybody can claim to be anybody, right? And you just showed the matrix link for the stuff. Like, would it be an idea to do this via matrix headers, right? It's already a federated system. You have different home servers and people have accounts that I say I give access to your matrix header to my document or something.
How would that work? Or like,
I don't know.
on what level would you do that authentication?
Like for the thing you don't know who the other person is. Like you type somehow to the matrix account.
I mean, you could tie it to all kinds of stuff. Like, but that's like I think the whatever classic DID thing is you tie it to like a domain registrar. But I think this is really not my particular area. But I think the identity threat model people are all like, no, it's not good enough. But I would defer to them on that. Who was next?
So regarding sharing a directory, you can share a single document already, right? So to avoid sharing a bunch of invite codes, maybe share a document with a list of invite codes.
I mean, yes, that's annoying.
Yeah, I mean, technically the applications do that for you, behind the back, but on the like protocol level, I don't think you need much more than you have already.
I think if you want to do it properly, you need access control somehow. But again, I'm the designer of the project. It would be great to have ATZ here.
The other thing about removing devices, what about removing users, which is, I said, just a group of devices?
Well, I mean, that's only once you have access controls, you can do all of that. Okay. But until we have access controls, we also don't have users. Okay. Everyone is their own thing. I think Ada?
Two things. Firstly, thank you for I'm going to go back to the beginning of the talk where you were talking about political solution or other things. Firstly, thank you for mentioning that because I think we are missing out on that. We need to do a lot more policy advocacy because a lot of the things that we get stuck on are actually fixable by policy. And I wanted to say if you have anything more to say, any concrete proposals for some people.
I mean, the one concrete that we are discussing with FSV and some other people is the bootloader thing, because I think on the phone side that's sort of the most annoying one. But I mean, yeah, there's a lot of stuff. Like you could, with this right to repair stuff, you could just force people to upstream their kernel shit. I mean, again, if you have the power of the state, you can do a lot of stuff. The question is how you how you get them to do that. But I think like we were thinking about it mostly from the mobile sort of whatever. How do we get phones to not be so awful point of view? Like whatever, forcing everyone to like boot the same way. A lot of things like that. We haven't super talked about it like in other areas, but I mean, I don't know. Outlawing credit cards would be great. I think there was a question back there.
And, sorry, second one. Don't do the file thing. The POSIX API file is not those words. Don't do. That's what.
I mean, let's talk about that later because I think it would be so cool. Everyone wants this. I mean, I know Jonas has opinions on this. Who was next? Do we still have time? Oh, we don't have time.
Maybe 1 more minute.
Okay, well, we started like 10 minutes late. I feel like we.
We started 32 minutes.
What? What do you mean? Did it start at 2:15?
2:05.
Oh, 2:05. 5 more minutes.
Couple more minutes.
Okay.
That's actually not a question, but I think the whole product can benefit from the concept of ownership. So initial creator has permissions to grant ownership to other users, just as editors or as owners. And that allows do not delete the document for all. I mean, when non-owner edits the document, he just unsubscribes.
So you can do, I think, all of potential whatever different configurations of this sort of access control stuff with the Spaces API. The question is, what do you want from a UX point of view? And I think like in our specific example of a cops are at the door, maybe you want whoever's door the cops are at to delete it. Maybe the owner thing doesn't help you, right? Like.
I mean, whenever in the current configuration, any user can delete for all, right? No.
Well, no, this is a proposed system that like could be built using this API, but you could build one where everyone's owner, you could build one where one specific owner, you could build one where you have multiple owners. It's not an API question, it's a UX question, I think. But like, it's a what do we actually want the system to afford to the people using it? And to that, at least, I don't see an obvious solution. Is that it? Do we have one more?
Yeah.
David?
When you just support for all the questions on like single software, and so do we actually do this? We need to stop working parallel and have more coherent collaborative work horizontally. But I have also a technical question. Do you have any do you look also into integrating with version control systems of any sort? Because it's like there's also a big chunk of people who use version control systems, and like it feels like if you use version systems, you can either have that or you have your app, or you have either like it or the.
We haven't looked into it concretely. Like we looked at it a little bit from the design side, like what would, for example, like some UX flows look like in this regard. We haven't talked about it in any concrete way though, and I think that is a whole long research project by itself, right? But I think it's interesting, yeah.
It also ties with the UI identity, because if you look think about like collaborative redistributed version control, then the idea of identity also ties in very well. So it also maybe solves the problem in some regards of big times between things.
Maybe. Do we have time for one more?
One more. Okay. Those supporting nodes in Panda, are they application specific? Do we need one supporting node that's made for reflection, one for any other app, or are they universal?
Ideally, eventually universal, to start with application specific. But also, like I think there's gonna be multiple layers of all of this. Like there's gonna, or multiple iterations. There's gonna be one hacky one that I think the pandas have already more or less planned out. They have like a better one they want to do later, and then eventually the idea is maybe this whole thing is like just a standardized part of whatever IDF standard something. Because it's all very generic, and I think everyone's working towards the same thing. Like the Inca Switch people, the Nextgraph people, they all have their own version of basically this idea. But I think it's gonna take some more experimentation for that to cause. All right, done. Thanks.
Thank you, Tobias. Thank you, everyone at home who's still watching us. We have a few people on YouTube and so many people here in the room. If you'd like to also sit in those chairs over there, you have plenty of space. Feel free to move around. Also, last reminder, people with the red lanyards, please sit on that side of the room so we can avoid taking pictures and you being in them. Otherwise, maybe, hopefully, we will not take pictures, but yeah. It would be nice to share something online of what's happening here, so many people. So yeah, we go on with the next presentation. Nicholas, hi. If you can join me on stage. If you'd like to step in the meantime.
from the project formerly known as the Cool Desktop Environment. So some of you might be wondering now, wait, this isn't Linux Desktop Summit, this is Linux App Summit. To which I say, we at KDE offer a lot of applications. According to our website, it's over 200. I haven't counted them all, but I believe it when I see it. Some of them are fairly old. I tried to find out which one is the oldest, but nobody could quite tell me. I checked some of the Git histories, and they go back to slightly before I was born, so that qualifies as old enough here. Some of them are fairly new, like Drawy, which is an application you can use to do some fancy drawing. Some of them are pretty big and featureful with lots of things you can do, like our email client, for example, which is also the older side. Some of them are fairly small and self-contained and just do one thing. Some of them are pretty popular with lots of people using them because they are general purpose tools like a PDF reader. Others have a more smaller target audience, like a memory profiler focused on programmers wanting to optimize their applications. Some of them are for creative-minded people, like Krita or painting application. Some of them have a more scientific audience, like an editor for statistics with R. Some of them you can use for serious work, like managing your money. Others are just for fun. But all of them have one thing in common: they want to be loved. They want to be loved by their developers and their users alike. So what do we as users want? We want, first of all, we want more Linux native applications. But also, I would argue, we shouldn't restrict ourselves to Linux. As people who want to spread free software in the world, we should also be targeting people who, for one reason or another, use proprietary operating systems like Windows or Mac OS or Android to the degree that you can call that proprietary. So I don't think we should limit ourselves, but we should meet users where they are and target a variety of platforms with our software and enable more people to use our software. Then, of course, we don't only want new applications all the time, we also need to care about and maintain and invest in existing applications so they don't degrade and get abandoned and then a couple of years later somebody rewrites them from scratch. And in general, we want, of course, a high-quality design user experience, makes it applications easy to use, a joy to look at. We want our applications to be accessible so that many people can benefit from them. And of course, a high quality, good implementation with lots of features, everything robust and doesn't eat your data. And developing an application alone is not enough. We also need to make sure that our applications actually reach the intended end users, which is not necessarily a given. So, every few years in KDE, the whole community basically gets together through a voting process and elects so-called goals, which are just areas of focus that the community wants to focus on for the foreseeable future. Now, this is not a top-down process where there's a project manager and a Kanban board where somebody assigns people work to do and then things happen. It's a more organic, ground-up community-driven process. There's like goal champions or leaders that sort of set the direction, but it's mostly a job of inspiring people to find their own way to contribute to that goal. So it's a very democratic process with not much top-down management. The last time we elected these goals was in 2024, and we elected the following three. One of them is called We Care About the Input, which focuses around the experience with input devices to make sure that touch screens, mouse, keyboard input, game controller input, drawing tablet input, all of these things work nicely. You have all the features available that you need and want out of that, and make sure that you can put your input into your computer in various different ways. The second one is called KDE Needs You, which focuses less on the coding part of everything, but more on onboarding people into the community and reaching out to, for example, universities to get people involved from a younger age already. And the third one, that's the topic of today, is the Streamlined Application Development Experience Goal, which is the one I submitted and I am championing. So before I tell you why I did that, a little bit about me. Hi, I'm Nico. I've been contributing to KDE since about 2017, so I'm approaching 10 years. I live in southern Germany and I work as a software engineer and consultant. And since 2023, I also work for KDE, the non-profit organization behind KDE. I'm paid as the software platform engineer, which is a fancy term that basically means I take care of common building blocks that all KDE software use, like Qt, KDE frameworks, various libraries and middleware things. I just try to make our software platform as nice as possible. And sort of as part of that, I came up with the streamlined application development experience goal. Now with all the things that I've said we want our applications to be and what developers want their applications to be, I don't think we are doing particularly bad in any of them. I just think we can do better. And sometimes when things don't quite work the way we want them to, we have the saying in KDE of, oh, why can't we have nice things? But I'm a firm believer that we can have nice things if we put in the work towards that. So if you wanted to summarize my goal in one sentence, it would be have nice things. Of course, it gets a little bit more into details, but first let's have a look at previous goals from the last years of this goal process. There was one called All About the Apps, which was a push to basically improve the presentation and communication and promotion around our apps a little bit. It wasn't so much focused on the actual development part, but mostly around packaging, metadata, getting applications to users. And we made some good progress on that. One of the first goals we had was the usability and productivity initiative, which is just about little things, little features, or streamlining the usability of our applications. Another one was consistency, particularly in the design of our software or applications, to make sure that KDE applications have a common visual and behavioral identity, so you can recognize a KDE application as one, and we don't have applications that do similar things, but in a different way. Then we had the automation and systematization goal, which was more like consistency of development process, so to say, to make sure that not every application maintainer has to reinvent all the things and all the tools and all the ways to build and ship the application. Then we had a goal specifically for accessibility, which I think mostly speaks for itself. And another one was onboarding of new contributors, which should also speak fairly for itself. Before we get into the details of the goal, a few technical words about our application stack. Most of our KDE applications are built using the Q toolkit. There's not really any particular rule that says it has to be that way. I'm not sure if there's a rule that says no apps need to use GTK, but that's just how it is in practice. And within Qt, there's sort of two competing ways of doing UI. One of them is the older Qt widgets technology, which is like very 90s object-oriented C++ API for adding push buttons and layouts and checkboxes and so on to the application. And it tends to produce which is just a much nicer way to express your UI. You still write your backend in C++ or some other programming language, but you have like a somewhat like HTML with some modern framework API just for the UI layer. And then Qt Quick sort of complements that as a more modern rendering graphics stack with hardware acceleration and shaders and everything. But both of them sort of coexist in KDE, which introduces some amount of awkwardness because some applications use that one, some applications use the other one, and then there's to the user inexplicable differences in how they look and behave sometimes, but unfortunately there's no easy way out of that. That isn't rewriting half of our software. Then on top of that we have libraries like the KDE frameworks, of which there are 73 currently, which are libraries for various purposes like implementing specific file formats like ECAD or iCal, or random widgets that Qt doesn't have but are useful for multiple applications, and really a lot of functionality that is shared between various KDE projects. And we use mostly C++ as a programming language, which is also maybe not the most appealing language to most people. More on that later. We use CMake as a build system. Personally, I like CMake. I know a lot of people don't, and I like to describe CMake as the build system C++ deserves. And for code hosting, we're using a self-hosted GitLab instance on event.kde.org, which we've been using fairly successfully for a couple of years now. Ever so often people come and say, oh, why don't you just use GitHub like everybody else? But we have this principle of only using free software for our development purposes. And well, if you look at the state of GitHub these days, it more and more looks like this is a correct stance to have. Unfortunately, if we look at the state of GitLab these days,
That's the code dark.
yes. So, let's get into the goals. I sort of divided the goal into 4 different areas. First, there is vision and design, which is basically asking the question, what do we actually want? This might sound like an obvious question, but in a community of hundreds of people with different opinions and visions and everything, this is not a trivial question to answer. And what I want us to do is things like settle on a specific design target for our applications, what they should look like. And personally, I'm thinking less in terms of how does a specific button look like, because I don't really care that much, to be honest, but more the application layout, the structure, and how the content and everything fits together. And that, ideally, that design is consistent to the degree that it makes sense across different applications. It also should factor in ideas like convergence, so running the same or similar software across a range of devices like laptop, desktop, phone, TV, maybe even a car, who knows where our software will get used. By the way, we have KDE software driving on the street in cars. And for a few years we've had this motto of simple by default, powerful when needed, and I think it's a good guiding principle of what I want my software to be like. Moving on, we get to the part where, okay, now we have an idea of what we want to build, let's do it, which gets us to development. We already have a fairly large and rich ecosystem of API. We have Qt, which has APIs for all sorts of tasks. We extend that with KDE frameworks and other libraries. We have third-party library components that we use, like Flatpak or AppStream or this and that. So we can already do a lot of things, but everything can, of course, always be extended, simplified, streamlined. Over the last few years, when it came to transitioning from Qt 5 to Qt 6, which is something we finalized a few years ago, we already did quite a big push in terms of cleaning up and streamlining, dropping old stuff in our own API. So we are already in a fairly good shape there, but there's always more we can do. And so the guiding principle I have is doing it right should be easy, doing it wrong should be hard. Then I've mentioned we are mostly using C++ as a programming language, which is not the most appealing language, I'm gonna be honest. I like what I can do with it, but not everybody does. So we wanted to also open the door for people to write applications in other languages. Now, program languages, there are many, everybody has their favorite, but we've identified 2 that are the most relevant candidates for for us to look into, and that would be Python and Rust, because they're fairly popular languages. Many people know them and like to use them, and they are also the two where there's the most prior art when it comes to integrating that with Qt and KDE code bases. And we want good tooling for building and deploying applications, good CI, static analysis, things that catch issues during the development of QA, and generally automate as much as possible the boring parts of the development process. Now, I know all of these things almost by heart by now, all the intricacies of KDE's code and why things are the way they are. But this is because I've spent many years spelunking in random parts of the code base trying to figure out, is this important or can we kill it? But not everybody has done that. So whenever somebody new comes into the community, they will ask, how does any of this even work? And to be able to answer that, we need good documentation. So what we want is to improve the documentation for all aspects of the development cycle, which is starting with design. We have a document called the Human Interface Guidelines, which a couple of years ago we completely overhauled and focused on the most relevant bits and pieces of that. Nate Graham did a talk about that a few years ago at LAS, so if you're interested in that, go check that out. And then going more to the development side, of course the most interesting one is API documentation. You need to know which APIs are available, which can I use, how do I use them, what are the pitfalls, and so on. But you also want more use case oriented tutorials. So how do I do things with the bus, or how do I access the contacts, or really anything. And so we have quite a few tutorials already, but some of them are outdated or too complicated or not complicated enough, and there's always ways we can do better. And we also want good documentation on debugging and optimizing and testing applications, and finally on publishing the applications to FlatHub, to the Google Play Store, to F-Droid, to Windows, and all of these things. And then we have the topic of community. So not only let's do it, but let's do it together. Because there's this old saying, go alone, go fast, go together, go further. And a few years ago at Academy, which is KDE's yearly conference, I had a talk that was basically saying KDE doesn't really have maintainers in the way that many projects have them, in the sense that there's a single person that is responsible for a given module, but our development process is more community focused and spreading various tasks and responsibilities among different people. And I think it's an approach that serves us well, because everybody has different strengths and people rarely want to be the sole person responsible for something, such as spreading the load and spreading things to where people have their strengths is a very good idea, which also makes us way more resilient against people leaving, for example. And in general, I want us to embrace community-based development, not only within our community, but also in our upstreams and downstreams and side streams, is that a word? And we need to work with our neighbors, which are communities like Qt, which is a community that's fairly close to us, but it's still a somewhat separate entity with their own people, own ideas, own development and communication channels. So we work together a lot, but we need to ensure that it stays that way and we benefit from each other. The same goes for communities like GNOME, XDG, Flatpak portals, the distributions, other Linux middleware communities like the printing people and all of the people that make up the wider Linux space. So this is basically the talk that I've given when the goal originally started, and I was laying out, okay, what we want to do here. Now it's more than a year later. What have we achieved since then? In terms of vision and design, not that many big things in terms of like grand vision, We have done some more technically focused work on, first of all, a design system, which is more design-oriented, working with a system based on Penport, where designers are thinking about ways to structure and formalize the design process. I've been not so much involved in that, so I can't tell you that much about it. And then more on the technical implementation side, we've been working on a new theming system that will allow us to make it much more easy and accessible to not only iterate on our own design, but also provide custom themes, which is something that's currently also possible, but it's very technical in the weeds and not very accessible to most people. And something that I want us to do, but haven't got around to actually doing it, is sort of an application design focused get together of people who are into design and want to discuss and sort of formalize a design vision for what we want our applications to look like for the foreseeable future. In terms of development, the area that has seen the most tangible work is language support. We now have language bindings for Rust and for Python. For Python, we're actually shipping them with some KDE frameworks out of the box with every release. With Rust, things are a bit more experimental, but the groundwork for using Qt and KDE libraries with Rust is there. It just needs extending and based on what use cases people have to use them with. So we have some building blocks there. They're not that well used because it's sort of a chicken and egg problem with the process isn't really streamlined and trodden out because nobody does it, and then you kind of need somebody to champion the whole process and say, okay, I'm gonna write my new application idea in Rust now and blaze through all the things that aren't quite optimized yet, even if that makes the development process slower initially because you have to figure out a lot of things. But once somebody has figured them out, the next person is going to have an easier time. But we have made also small and medium-sized improvements to our APIs across the stack, making it easier to, for example, to avoid some boilerplate that you find in every application's main function to set up a style and this and that and a random Windows workaround. So now we have a more central point where you can do all the things that everybody needs to do, but you can't really put it in a central place for reasons. We also have made some good improvements in terms of IDE integration and tooling for specifically the QML programming language, because a few years ago IDE support was very, very poor with basically any IDE. You got syntax highlighting if you were lucky, but autocomplete or saying that your name is wrong, that just didn't exist, but it does now. We have a language server for QML and a linter that spots out issues and errors, so a lot has happened there. We also have some more extensive CI verification. For example, we started to add like little smoke tests in the CI that just open a system settings module and see does it immediately crash or error out. Or we can check for memory leaks on CI now just by not disabling the leak sanitizer that we have. And that sort of thing, QML integration and CI. But there's more we can do there. So quite a lot of stuff has happened in terms of development. When it comes to documentation, the main thing that I was working on is a relaunch of the ape.kili.org site that posts all of our technical API documentation. The old system was built on Doxygen, which works okay enough for documenting C++ API, but it struggled a bit with Qt-specific concepts. And for QML API, it doesn't support QML. We had a very, very, very ugly workaround for that, which didn't deliver any good results. So that was really a sore point in our documentation story. But since then, we have completely overhauled the site based on a new tool called QDoc, which comes from the Qt project. So of course it understands all of the Qt-specific things. And now we have much, much, much better API documentation, particularly for QML APIs. We also have some new and improved tutorials on develop.kd.org, which is the part of our documentation that hosts more tutorial-based and use case-oriented documentation, so anything that is not automatically generated from source code. But we still have a fair amount of content that is old, outdated, still about Qt 5 or even older, or just API that doesn't have any documentation comments, so there's still quite a few gaps that we can fill. And we have quite the amount of documentation spread out in API.kd.org, develop.kd.org, various wikis and readmes and so on and so forth. What I would like to see is like a one-page landing website that just goes through the development process, starting with like design conception over development, debugging to packaging and publishing, and just links to the relevant documentation that we have so that it sort of ties everything together. In terms of community, I'm proud to say our community is awesome as ever. We are trying very hard to welcome and guide new people into the community, which I think is not an understatement to say we've been, over the last 30 years, fairly successful at, in the sense that multiple generations of people have left and were replaced with new people, so that the projects stayed alive, and we're doing fairly good with that. But of course we can always do more. We're already doing, but we should do more, extend outwards to what I've mentioned before, extending outward to Qt, all of the Linux ecosystem. And I've noticed an uptake in us attending events like Qt Contributor Summit, this event, conferences like Oxidize, All Systems Go, really anything that's in our mindshare area. So, what does the future hold for this goal? The sort of formal part of the goal process will stop eventually, just because the time is up and it's time to elect new goals. That doesn't mean that the work has to stop, and it's still a community-driven process where everybody can get involved and do things. And so the seed for this is planted. Now it's up to people to help it grow. And we should just keep attracting people that want to build things, make sure they find a nice, welcoming environment, both in terms of our technical infrastructure and also the social community, and always look for opportunities that we can improve. And with that, I'm at the end. Thank you for listening to me, and I'm happy to answer any questions. Yes?
I'm from the non-design team, and we plan to look into PenPod as a design tool as well. I think even though our design systems are very different, it might be a good opportunity to exchange some thoughts on this. Who should I contact?
Andy, do you know Andy Betts?
Not yet.
I can give you a contact. That's sort of our main designer, and who's working on the PenPod stuff and the design system there. We're running into some interesting challenges with PenPod, like apparently quite a lot of performance problems we run into, and we're also in contact with upstream PenPod, and they promised improvements but haven't materialized, so there's definitely room for working together there, but also room for just us users of PenPod working more closer with the upstream to make sure that things are nice and competitive against the proprietary alternatives. Yes?
Do you have a time frame for the design part of creating a new thing? Because right now, my situation is if I want to create a new app, right now I would choose GNOME, because the GNOME design is fresher, modern, more approachable. I have components that I can put together, it's really well thought out. And I tried to do it with KDE 2 months ago, but I couldn't because it felt like the best comparison would be an app from 10 years ago. So there's work to do. Do you have a timeline when you
I don't have a timeline where I can say by this point in time we will have this or that.
No, but do you have an idea? We will try to do this in 2 years, 3 years. Because right now
I mean, there's work currently undergoing in both the design system part and the sort of design implementation part, but it's very hard for me to say when that's at a point where it will result in anything you will notice in production. So really hard to say, just because it's work done by volunteers with nobody's particular timeline or steering or anything.
So you mentioned like that you would like to ship applications also on like Windows and Android and stuff like that. Because we've been also thinking about this specifically in the context of Android and the mobile first apps, because they are really useful that way. But I don't think like on GNOME it doesn't really work well currently. And I'm just curious what you are doing there to make this happen.
So with Android, the thing is, Qt has supported Android for like more than 10 years, so a lot of the fundamental technical things are squared out. A couple of years ago I was pretty involved in KDE apps on Android, also like because of synergy with things like Plasma Mobile and Mobile Linux, because we had mobile focused applications anyway, so why not put them on Android? And right now it's at a state where we have a bunch of applications where we produce Android APKs, but nobody feels really quite confident enough to say, okay, this is something that I can actually give people and they will like it. It's like at an 80 or 90% state, and it needs somebody to care enough to push it over that finish line. So there's some technical work to be done just on finishing bits and pieces, but it's mostly somebody needs to care enough to push the little bit over the finish line to make them truly shippable.
Because like one of the things I think is a bit of an issue are like the APIs that you can use or should use. For example, if you use Apollo APIs, they're obviously available on Android and stuff like that. So I think those are kind of the bigger hurdles for us at the moment, I think.
Yeah, so you would have to find abstractions on the library level that work with what portals provide on Linux and what Android provides and so on. Qt does a fair amount of that out of the box, like file dialogues are a solved problem at this point, but many things are not. Yes?
Yeah, so two questions also in this direction. First, you mentioned Android, Windows, Mac OS. What about iOS?
The thing with iOS is pretty much always nobody really tries to do it. If somebody really wants to, they can do it, but it's such an inaccessible development platform for most people that it's very hard to do anything unless you really care about it. Technically, with Qt, it runs on iOS. You can totally write iOS applications with Qt, and the KDE stuff we have on top. There's no, for the stuff where it makes sense, there's no major reason why it wouldn't work on iOS. It's just that rarely anybody ever tries, but if somebody's motivated enough, they can do it.
Okay, and then the second question, you had mentioned the Rust and Python bindings now. Do those bindings also work for all platforms, or are they restricted to them?
There's no reason why they wouldn't work on all platforms. I'm not sure to what degree we have actually tried to ship them. I think Tobias built the NeoChat stuff for Android.
Specifically, it works fine on Android.
Yeah. I mean, at some point it's just, you have your CMake build system that internally calls cargo, and assuming that you tell it just build for Android, it will do that, so it's not a major problem.
You get the occasional weird linking, compiling failure, but there's nothing really stopping it from working.
Yeah, I'm not sure to what extent we have tried to build it for Windows and Mac, but
Windows, yes, Mac.
there's no major reason why it wouldn't work. It just needs somebody to sit down and shepherd it through the process. About Qt development experience, is there any plan to avoid forcing non-KDE Qt apps to end up with KDE platform choices? Style, CSD, SSD. Avoid forcing non-KDE. I'm not sure how that question is meant. When it comes to
I mean, if you're a Flatpak app, then we will not load platform integration into it, right? I think that's the question. Like, if you're a Qt app running on Plasma, our platform theme will run in the app and
Right.
choices for it, right?
So, one pain point that we have a little bit, and maybe the question is getting towards that. If you run a Qt application on a Linux platform that isn't necessarily Plasma, the result of what style is used, what file dialog you get is sort of vaguely defined, because Linux as a platform is sort of vaguely defined. So what a lot of people do is, the KDE specific Qt integration solves a lot of things. So what some people do when they run Qt applications that have nothing to do with KDE on Linux is just pretend that they're running on Plasma, and then some things happen to work better than they do without that. It's a bit of a complex problem space in both directions, both the question of running Qt applications or KDE applications outside of Plasma, and there's differing opinions on what the correct result or the intended result is, so it's not easy to please everybody out of the box. Thank you.
So hello everyone and welcome back. I hope people can hear us online in the streaming. Please give us a sign if you do. And we're happy that you are still sticking around because we have a very interesting talk. Now we have Ishan Sawan and he's going to talk about EU is breaking up with MS Office. Here's what works for Linux users.
Guten Tag, Germany. Guten Tag, Berlin. It's great to be here. It was a mess. I just got my visa a couple of days ago, and I had to, change 3 flights. I've flown all the way from India to talk about Office Suites. Is there a way I can take this mic in my hand?
Yes,
I can. The organizers are gonna hate me for this because they'll have to. But yeah, I've come all the way from India to talk about Office Suites, and I'm going to talk about how there is a revolutionary change happening in Europe. Everyone is moving towards digital sovereignty and all of that. I'm Ishan. I work as a community engineer, developer relations, evangelism at Only Office. I'm also an open source enthusiast. I've been a maintainer for a lot of open source projects, but as of now, I maintain 2 projects in the CNCF Foundation. As a hobby, I love traveling, and that's also part of the reason why I'm here. So I don't mind changing 3 flights to just come to Berlin. But, in Europe, there's a revolutionary change happening. Everyone is talking about digital sovereignty. Everyone is talking about open tech, open source. People are starting to understand the importance of having choice, the importance of the ability to control what they are using, and you can see it, right? The numbers talk. So we talk about Schleswig, if that's right, Schleswig-Holstein. 30,000 systems. They decided to move it. And they just ditched Microsoft and move it to something open source. I don't know if you might have heard it, but there's a city in France, it's called Lyon. The whole government of Lyon, overnight they decided that we are going to move to open source. We are ditching Microsoft and we are ditching the hyperscalers, we are ditching the proprietary tools. So they decided to choose a stack which included, I think, Linux, PostgreSQL, and Only Office. The change is obviously happening, it's gradual, but I think they aim it to do it by the end of this year. And obviously the Europe Interoperable Act as well, open standards, open tech has been preferred time and again over the hyperscalers and their options. And I think they're also in talks to make it mandatory by 2030. So yeah, it's happening, and I think as someone who has been in the Europe ecosystem, it's part of everyone's duty to kind of support what's happening. And when we talk about the whole Digital Sovereignty Act and the shift towards open tech, it's all the things, right? Files management software, it's going to be the cloud, it's going to be everything, and so document editors, Office Suites, because at the end you need a way to work with your documents and everything. So that makes documents and the things that we use to edit documents and work with documents really important. And that's why I think when we talk about adopting open standards and open source, documents and things, document editors and Office Suites are going to be pinpointed and picked up first, because if consider a big institution or a school or a college, right? How they need agreements, contracts, maybe even salaries, and everything goes into documents. When you talk about small to medium-sized businesses, SMBs, right? It's their reports, it's the salaries and how they talk with each other. Even about when we talk about personal use, no one is going to write a letter and attach it to a pigeon and then just hope that it reaches the friend. I mean, obviously, you're going to do it online. You need a quick way to send that particular text file to your friend or to anyone who you want to collaborate with. So you need something that will help you work together. So obviously documents are important, right? And how do you edit documents? Right now it's Office suites, things that help you edit documents. Right now, if I were to name some popular ones in the open source, or let's say when we talk about sovereignty, there's LibreOffice, there's Collabora, there's obviously OnlyOffice as well. So again, but when we broadly look at it, there are still some problems that are kind of a barrier for people to freely and move to open source and ditch the hyperscalers altogether. So obviously this is not for a particular software, it's more of these problems exist throughout in different softwares. So let's say AI, right? So a lot of open source editors and document editors don't have AI today. Because and I don't, for example, Libre. So Libre is a completely community operated project, and I don't blame them because again, there is so much that you can do. So AI is not what they're looking at right now. If you talk about UI, well, UI and UX. So something like OpenOffice, a lot of people say that where it has a bad UI. Again, it's just there. There's merit and demerit. So when you talk about formats, there is so many formats. So for example, if you are working with open document format, and your friend is, let's say, still using Microsoft, it's going to be a trouble sending him files and then kind of getting them back. So there's problems that exist throughout the whole open source document editors, but the most important problems are these, like real-time collaboration, AI. But and this is this table that I made last year when I was giving a talk at Gnome Asia. But again, not going through in detail because obviously one has something, the other lacks something. So yeah, and obviously this might not be very pretty accurate as of now. It's from last year, but just to give you an idea of what is missing, what each one of them has. But right, I mean, again, I work for OnlyOffice, and again, I'm not here to give a product pitch. We already know that I had 10 people come to me today and say that, okay, we use yours over Libre because we know that you are addressing these problems. But again, I don't want to make this talk a product pitch because no one is interested in a product pitch. I want to talk about how what are the engineering decisions that we took, what are some certain changes that we made, what are our principles that we stuck to, which helped us make what we have today, and what you people can learn if you are working towards an application or maybe are a maintainer of some project or an application or any of that sorts, right? So again, yes, we make open source Office suites as well. You can use it on an array of platforms. There's a lot of distributions with Linux, Mac OS, and Windows and all of that, right? But when we first tried creating an Office suite, there was this immediate argument. Do we want to stick to open document format? Have you heard of the open document format? So that is the most popular open format that open source editors use. So do we want to stick to open document format, or do we want to do something else? And that's when Microsoft made the OOXML standard open source as well. So when we first started out, we were pretty sure that we wanted to use OOXML as our standard. And how that helped us is that, so if you talk about the traditional approach, what happens is you have a docs file that someone sent you. So if you were to open it in an editor which uses the open document format, there is an internal parser, so it kind of converts the docs file into through the internal parser into ODF, let's say ODT or ODS or whatever, and then that you make changes to that, and then it is again converted to a docs file. Now what happens is, in every single stage there is a loss of data, there is a lot of structure, there is a lot of styling. Okay, what we did different was, so obviously Microsoft had made the OXML format as open source and open for it.
That's not, it's an open format, it's not open source.
It's not, it's an open format.
That's a difference.
Sorry, it's open format. I just had a slip of tongue. It's open format. But yes, it is open format. I meant open format as well. So Microsoft, it was open for everyone. again, but the internal parser was something that you had to create on your own. So what we did was, because the docs format is a zip of multiple XML files, what we did was in the XML, if you see, so when you open these zip of XML files, what you get is basically a structure of all the elements. So there's paragraph, and then there's run inside, and then there's a word inside, right? So what we did was we basically mapped each element to one single class in our JavaScript. So for every single document, we formed a whole JavaScript tree, and then that tree was in turn modified, and then you get a docs file. So what happened here was that the fidelity and the compatibility with anyone who worked with Microsoft was 100%, but also if you were to export it in an ODF format, right? ODF is comparatively easier to manipulate than OOXML, because OOXML has a lot of complications and caveats. So what we did was we kind of mastered the OOXML format as well, and then you could also work pretty well with the ODF formats. That's the first thing that we did eventually. The next is live collaboration. So because we have this whole OOXML and we kind of had this JavaScript tree, what we did was, instead of using OT, which is operational transform, what let's say Google Doc uses or any other real-time collaboration tool uses, what we did was we mapped each paragraph, each run with let's say a ID, and that was basically the ID of that paragraph. So then if it was edited, it was replaced, then it was pretty easy to identify who replaced it and where it was replaced. And if it was deleted, then that just means that the ID did not exist. So that way it was pretty easy to integrate real-time collaboration. When we talk about operational transform, it is obviously what all the hyperscalers use, but again, it has subtle errors, it can generate subtle errors, and if two people edit it at the same time, things can go messy if it is not mastered in the right way. So that's one thing that we did. So that's about the collaboration and the real-time editing. When we talk about AI, last year we started to integrate AI. We started with ChatGPT, the API, and we hard-coded it as our AI plugin. But then later we realized that people in Europe need more. It's not just ChatGPT, but they need options. So what we did was we separated the AI logic into a plugin. So the editor sent a post message, and that's how, and the editor basically didn't care which AI it interacted with, right? So you could probably connect OpenAI, Anthropic, Olama, anything you want, even your custom model. So the AI plugin was isolated, and a plugin is basically a JavaScript file with some CSS and an HTML. So it's basically like a simple web app, and these plugins are similar to what VS Code extensions are, what Figma plugins are. So it basically works on a post message. So that's what we did. So initially we started out by using ChatGPT and then OpenAI, but then later we shifted to having multiple models, and these are all the models that you could see, and these are all the providers that we support as of now, right? So again, we gave the users a lot of choice. And when we talk about more of the developer side, we have a lot of SDKs as well. We decided to, Microsoft obviously had macros, VBA macros, but we decided that our macros would be in JavaScript. So if you are someone who is not from the programming world, it can be hard, but if you are a developer, it gets ridiculously easy. So you can literally integrate Node.js, you can do a lot of things with just macros, and the plugins are basically like a parent of the macros. So it's just JavaScript plus some CSS so that your plugin can be visible, and all of these, the macro and plugins kind of modify those objects that I talked about, the XML objects, and you have a lot of methods as well to play around with those objects. So we have a whole API reference on our website that you can obviously use and create your own macros and plugins. So again, a lot of customization. And when we talk about integrations, again, we were pretty sure that we wanted OnlyOffice not to be a product, but also to be used in other different platforms as well. So how we handled integrations was we just introduced it using JavaScript Web Token. So basically, let's say the provider, right? So for example, you're using OnlyOffice with OwnCloud. So or let's say Nextcloud. So what they do is basically the authentication is handled by the platform that you're using it on, and it basically works on a JavaScript Web Token. So it's basically an iframe, and OnlyOffice just edits documents, and that what they do best. And that resulted in having multiple integrations over a period of time, and that's just some of them. But I think today it's 50 plus. You can obviously self-host all of this as well. Self-hostable because it's open source. I'll show you a demo later. But the point is that you might think that, okay, well, this is a free Office suite, it's open source. Windows users might be using it, or let's say Mac users, people who don't have a subscription. But for us, it has been that Linux users were one of the top users when we decided to do a census of it. And the reasons are pretty evident, because Linux users are the people who get into the geeky stuff, right? Plugins, try to make integrations or try to make something work with macros. So that was the reason why Linux users were one of the top users when we talk about using OnlyOffice. And that is why we also, and right now if you can see, we come pre-installed on a lot of Linuxes, and also available as snap packages for Debian and Fedora as well. We also have an app image, so that introduces diversity, and you can use it on a lot more distributions. But again, that's our GitHub. You can obviously check it out. Check us out on GitHub. But what were the things that we did that helped us become one of the most used Office suites today? First of all, it was understanding the user. So we immediately knew that people are looking for compatibility with Microsoft. As much as we hate it, and we want to move to a sovereign and a more made in EU tech world, people are looking for compatibility with Microsoft. So we decided from the very start that we want to stick to OOXML. And there have been a lot of arguments that, okay, but OOXML is a format still given by Microsoft, then how is it truly sovereign? But again, that's a problem that we are solving, and that is what we wanted to stick to, and that is what we decided to stick to. So we understood that people need it, and that's why we did it. And Compose Not Conquer is basically, we did not try to make a whole Office suite and then also a storage solution and everything all together. Obviously we have a file storage solution now, it's called OnlyOffice Dockspace, but it was not there initially, and we decided that we let users choose. If you want to use something else, you're free to. Even today, you can use OnlyOffice with, let's say, any file sharing solution. You can use it with OwnCloud, you can use it with Dropbox. There is also Box as well. So again, yeah, we composed it, and we did not try to kind of make it compulsory to use a particular workflow. Freedom. Through all the slides that I explained, plugins, be it macros, it was pretty evident that we wanted user to customize and choose what they want to do and just take it in their own way, right? So even with AI, even with the add-ons, so you can make your own plugins. It's really just a JavaScript file, CSS and HTML. You can use any AI model you want. You can just integrate local AI as well, or any model that you have in your system. So choice is what helped us win over the Linux users. And the last one is having a defining capability, right? So from the start, as I said, we were pretty sure that we wanted to stick to OXML, and that's what has made us different today. So that's why people have come up and said that, okay, well, this works better, and then that is why we want to kind of stick to OnlyOffice no matter what and all of that. So again, a defining capability that we had, OXML, we stuck to it, and we still are on that. And that is something that maybe you can learn from the journey that we have had. Again, that's my LinkedIn and GitHub, but I'll just show you how the whole Office suite is put together today. So yeah, so this presentation is also obviously made with OnlyOffice, but just to give you a quick demo for people who have never used it, that is how it looks like. It opens, so every single editor is bundled under one single application. It is pretty weird that I'm bringing a MacBook to a Linux App Summit, but because I'm working on the MacBook application right now, I have to, so I have a different PC as well. Don't judge me, please. But yes, that's how it looks like. We have editors, we have the document editor, spreadsheet editor, presentation. You can even view and edit your PDFs. It is all bundled under a single application. Cool. So just to talk about the AI agent, so this is something we have introduced. Again, you can completely choose which model works on this, but what you can do here is basically something similar to Claude work. So I can put in something like, go to my downloads folder and search for all the text documents and list them and open them. That's what it will do, right? So let's actually try it. We have 50% chances that it will fail. Oh, it works. Yeah. Well, again, it's the tokens, right? So let's try shortening it down. Download. But yeah, that's the AI agent. If you connect the right agent, it's supposed to work. You can obviously open your local file. There are multiple templates you can work with. If you go to clouds and if you want collaboration, you can choose from a lot of clouds to connect with. So that's the list. There's Nextcloud, there's own cloud, Moodle, LiveRay, C-File. So that's how it looks like. And if you, let's say, open a new document, that's how it will look. But let's try to open up a template and try editing it up with AI, because that's something that we can maybe, yeah. So just to give you an overview of how the AI plugin looks like, you go to plugins and that's your plugin manager, and that's going to be your AI plugin. So as I said, we have isolated the AI logic, so your editor doesn't know what AI it is talking to. That's the AI plugin, so you can just install it from there. I'm not going to update it to not cause bugs, but then you can see this AI tab, and you can go to settings and completely customize which models you want to use and work with. So I have OpenAI because I have a corporate key for it to test the AI plugin, and that's what I'm working on. So let's try using that. So, and again, you can set it for everything. So for chatbot, I've set 5.2, but at the same time for image generation, you can set, the image generation model of, yeah. So you can do that, right? And let's try doing something like, so by the way, I opened that prompt by command and slash. So we do something like change this to yeah, so that's how it works like, and this is just a simple operation. Just to make sure that it works, I did a very simple operation, but that's how it works. That's our document editor, and obviously you can look at different editors. You can just install it. As I said, you can install it in multiple distributions and platforms. So just install it, try it out, and yeah, that was the demo. Let me open my presentation again. That's my GitHub and LinkedIn. And yeah, that's pretty much it. I kind of finished quickly so that I can do a lot of questions, because there were a lot of people that were coming in to ask questions. So I thought it's a great time to just ask a lot of questions and just interact. So thank you.
You're here from OnlyOffice, right?
Yeah.
So what is your stand on the acquisitions? OnlyOffice is a Russian-owned company.
The gentleman right here asked, what is our response on the sanctions that EU has on Russia? You say?
On the owner of the company. So, according to the TU Berlin, they closed all cooperations with only office because of the acquisition that the owner is a Russian old company.
Well, we have been asked this time and again multiple times, and we also have a blog post in it that our owner is actually from Turkey, and all the investors are also from Turkey, and our developers are from Russia. There have been claims that the comments in our code are in Russian as well. But again, if you talk about Russian, it is spoken in multiple different countries and not only in Russia. So we have had developers from countries like Uzbekistan, even a lot of places. So just the comments alone, I don't think prove anything. But for the sanctions, yes, we had businesses with Russia, but we closed it late 2021. That's completely a different product now. It's called something else. We don't even know the name. I don't even know the name, but it is called something else, and it is completely operated as a different entity in Russia. Only Office is now registered in Singapore, and it operates under Ascensio Systems Private Limited, which is a company registered in Singapore in 2021, and we have no whatsoever connections with Russia. So I think that, well, apart from the geopolitics, at the end it is open source and it's a great open source product. But to answer your questions, I don't think there's any such connections with Russia which are concerning, and what you're talking about is. Did I answer your question?
It's your point, so it's fine.
Yes, I'll just come to you. Yeah, please.
I would like to ask a little different, but like similar question, and that is about Euro Office and like how does Omni Office take the development progress on it?
Yeah, I mean, thank you. So just to repeat the question, they're asking about the developments of Euro Office. I am assuming everyone knows about Euro Office, but I'll just give some context. Euro Office is a new office suite which is forked off of our product, Only Office, and whatever is going on officially is going on officially. So whatever our stand has been is we have been publishing it through social media and blog posts. But if you were to ask me, well, why are we all here? Open source, right? And at the end, open source is winning. So we are having good choices. So let's say even if everything works out, the better of the office suite is going to win. And at the end, people will use what is better. So I think, yeah.
But the problem is, you're talking about that we need to get rid of US, and then we have a company that hides the fact that it's a Russian-owned company, and then here talks about open source, and then there's Euro Office that says, sorry, we tried to collaborate with you on the open source stuff, and you never accepted anything from outside, you never collaborated with anyone. So the Euro Office people say Only Office is only open source on paper, not in practice. That's a difference.
Oh my God, I wish I was the owner, but I get your frustration. But again, about the open source part, we have a GitHub organization profile. You can go to GitHub, you can check all the repositories that are there on GitHub. It's absolutely open source. Just a second, please. It's absolutely open source. You can double check it. Yes, we have an enterprise version, but again, that's a model that not us but a lot of other companies have been following. And about collaborations, well, that's something that I'm only an employee at the end. So that's something that I can't answer a lot on. But again, yes, it is open source. You can go on GitHub and check it out anytime. Does that answer your question, sir?
No, but yeah, I made my point.
Well, yeah. Please.
Yeah, I wanted to follow up, but I'm like, if there is like some effort to address the issues that the Europe is brought up before, like why it was created, because like they had some points there, like commit messages being just like ticket numbers with like collections of like changes, the project not accepting pull requests and stuff like that, because that makes the project really like not open, and like that's why your office was created, because people couldn't add the stuff that they wanted to add into the project.
Just to repeat their question, you're asking about the fact about what Only Office is doing to address what your office is doing, and the reason why your office is created is to address the problems about not being really open and all of the commit messages that you said. I hope people watching online heard it. But again, as I answered them as well, that it is open source, it is on GitHub. About the contributions, well, that's something that, again, not even I am aware of, but it's open source, and as for the commit messages, they might be something that are concerning, but again, as I said, it's on GitHub. And about the Euro Office issue, whatever is going on, it's going on officially, and I think the last development in it was we had an update on it about, we just made a blog post about it. You can just go read it on the internet. It was in reply to the latest, everything is on our social media and blog posts. But again, we are, I think, looking at it legally as well. But again, as an employee, I don't have much details on it, and whatever official announcement would be made through the social channels. So yeah, and I think it's also a great time to avoid any more questions on your office, because again, that's something which is between the company and the other company, and this was just to talk about our journey, about how we made something good that a lot of Linux users are using. So it would be really appreciated if there are no more questions on your office. But again, if you have any questions on anything else, the AI and the local, whatever else, I'm happy to answer. Please.
So from the design of the app, it looks like with the colorful header bar, it looks a bit like Microsoft Office, I think. Was it a conscious decision? So people that come from there, it looks similar?
Thank you for a really good question. Again, yes, just to repeat this question, Only Office, the UI and the UX looks and feels pretty much similar to what Microsoft Office is and has been, green for spreadsheets, orange for presentations. And yes, that was deliberate. The choice was deliberate, again, to target a certain set of users who are or have been using Microsoft, but are shifting to Linux, or maybe just want a free option on their Windows laptop or PC, and just to help them and make it easier for them to use and get along with it in a much more quicker way. So yes, that was deliberate. Any other questions? Yeah, please.
How about compatibility with existing more complex documents, especially spreadsheets with macros?
Sorry?
Compatibility with complex Microsoft Office documents, especially spreadsheets with macros.
Yes, so as I said, because we follow the same open format that Microsoft follows, OXML, the compatibility is almost 100%, but there is, again, 1 or 2%, maybe a cell or two can be shifted when you talk about complex spreadsheets with a lot of tables and a lot of diagrams. Yeah, it should be fine.
And he asked me about macros.
Macros?
Macros. So this
Visual Basic VBA.
Yeah, there are macros for spreadsheets as well. And as I said, There are macros for spreadsheet as well, and the macros on OnlyOffice work using JavaScript. So you can create your own macro. You can go to our API reference, and there are a lot of methods that you can choose from, and then create your own macro using JavaScript.
Yeah, but I know a lot of companies have already complex document, and if they want to migrate to OnlyOffice, then they need to rewrite the macros in JavaScript, or is there some migration path?
Thank you for the question. So he's asking if a certain company already has macros for some complex macros for spreadsheets, and if they want to migrate to OnlyOffice, what is their option? So two options. Right as of now, we have the AI converter. If you go to macros, you see an AI option, so you can just put in your VBA macro and it will try to convert it into a OnlyOffice macro. But again, because it is AI, accuracy isn't guaranteed. You can try using Claude. Really works well with converting VBA to OnlyOffice macros. But yeah, we do have our AI tool. But apart from that, option number 2 is if you are in future if the company is going to consider our enterprise plan, then we take care of all of it. We take care of giving you the same macro that you had on the Windows PC, on your Microsoft Office. So yeah, 2 options. Any more questions? If there are no more questions, I think it's a good time to stop speaking. Again, if you have any questions, you can obviously reach out to me. If you want to see some open source work, real open source work that I did, you can check my GitHub. And if you have any more questions, or if you want to just stay in touch, you can scan the QR code for my LinkedIn profile. Thank you, and I hope you have a nice day.
direct train to go there, or like all the way to
So yeah, we're ready to go with the next presentation. We're going to hear Evangelos Patirakis talk about digging through the app symmetry, sustaining a fork.
Hello everyone, please bear with me, this is my first in-person presentation. My name is Evangelos Patirakis, or I go online by GeoJR. I mainly contribute to GNOME. I maintain some apps, and today I want to talk about some forks and how to properly do a fork, what needs to be done, especially for FlatHub and other app stores, and how to prevent these apps from dying, essentially. I think we've all seen many apps die, come and go, and some of the apps I maintain, I inherited the code bases, and I think I have experienced the ins and outs, and I can probably give this talk. I'll start by saying what prompted this talk. The last year I've been pretty inactive in something. And in December, to take my mind off things, I decided to fork, to continue an app that was very popular, Metadata Cleaner. Metadata Cleaner was a lightweight app that had over 300k FlatHub downloads, and it was included by default in the Tor distro, the Tails OS. At the time it was really popular, but at some point it died, with nobody really wanted to take over, and distros continued shipping it to a state that was very rotten, I'd say. Lightweight styles were missing and stuff, but distros continued shipping it, even though they shouldn't. So I forked it to Scrubber. I redesigned it. I fixed bugs and stuff, but I made some mistakes at some point, and I ended up archiving the too. So, which gets me to my next point, which is that apps die, and that's actually okay, and I'd say it's actually pretty healthy for our ecosystems, which I'll get to in a second. But first, let me start by showing some stats about our platforms. FlatHub reported in 2025 that 450 new applications were added, which is a huge amount of applications in terms. Obviously, the stats are not really representative because it includes proprietary apps, but they give us a clue about how our ecosystems are thriving in a way. According to our Really by Weight there's been 500 Weight apps, and I've seen quite a few Kirigami and other platforms for other platforms applications. This shows that we are still living through a big boom of application development, similar to those of the Apple ecosystem, and it doesn't seem to slow down really. But at the same time, we have to face the negative parts of all of this. Since 2025, there's been 200 EOL applications on FlatHub alone. That's almost half of those that were added in 2025. Obviously, that stat is not really representative either, because apps get EOL'd for app ID changes and whatnot. However, our runtimes are also experiencing some apps that are not really being maintained. They depend on deprecated and runtimes. About 10% of its runtime has apps that depend on deprecated versions. Which gets me to my next point, which is that I strongly believe that death is an opportunity in our ecosystems. I know that the title and the contents are a bit depressing, but I really believe that death is an actual opportunity. New contributors step up, and maybe they weren't interested in app development, but their favorite app might have died, and they gained the experience needed to start contributing and develop their own solutions. Sometimes apps have a lot of baggage and need support many workflows, but by starting a new application or a new fork, it allows you to start to implement new ideas that you couldn't be able to do before because you had support of those already users. And something we see a lot at GNOME is that core apps usually, when they die, new ones sprout. We've seen Decibels come from Totem and Showtime, which I don't think we'd have if Totem was kept being maintained. So let's start with the do and don'ts of forking. There's quite a lot of, well, distros don't really care about many of those, but FlatHub does. You have to always check. You have to always check if there's other efforts being done for the same app, as you would have more than one forks that achieve the same thing essentially, which is something I didn't do. A few weeks before I submitted my fork, I was informed by the Flatpak reviewers that there was another app in the queue that also used the same app ID. And it turns out it was actually a continuation project of the metadata cleaner. So the other thing that I didn't do was that I didn't ask for permission for the app branding, which I should have, and essentially had to rebrand midway to Scrubber, which is very last minute. It's important to always contact the previous maintainer. When I forked Tuba, it wasn't really... The maintainer was still active, and he helped me a lot with getting stuff started, and he actually contributed a lot later. So it's a good way to... It's a nice thing to have contact with previous maintainer. Sometimes apps on the way out leave a lot of PRs open and that never get merged, but were actually good to go. So you have to go through those and pick them apart and see what you can actually cherry pick and what can be fixed. Which also means that you also inherit the bugs the app had, and you have to go through that issue tracker too. And the reason the other metadata cleaner fork wasn't merged already was because it didn't really do much. It just changed some metadata and called it a day. So you have to actually change things, change the design, prove that it's not a random fork that's going to die in a week or two. So let me get started with the unwritten rules, which is mainly social ones mostly. First of all, you have to make sure the project is archived. Sometimes maintainers just take a big break or they're tired, and then the project might seem dead, but it's not really. So communicate and actually conclude that it's not going to get any updates. Another thing is that single issue forks never really succeed. I can really name those that have. It's easier to name those. It's like LibreWolf, VS Codium maybe. All those counter forks really die one way or another. Rarely we succeed. It's good to keep good relationships. You shouldn't really sift the blame of bad code bases and bugs. It's really your project now. Keeping the credits around is always a good thing for collaboration. You shouldn't scrap the previous maintainers away. They still did a lot of work on that project. And lastly, don't claim that you are approved or something, because the previous users of the app had a trust relationship with the previous maintainer, and if you break the trust, eventually you're also severing relationships with the previous maintainer too and their users. So now it's the time to talk about sustainability. The best thing always is to really not get apps killed, even though there's some good things about that. So once you fork the app, how do you prevent this from happening again to you too? So you have to get comfortable with code base for starters. I think Dino last year, the XMPP client, supported both Meson and CMake, which really, if someone forked that app, for example, should have removed stuff like that. It should remove linters you don't like, and anything else that could create friction between you and maintaining the app that it's now under you. It's always good to follow today's practices and really stop supporting older distros because the previous app did. Bump the dependencies to the latest version. It's okay. FlatHub, you can ship to FlatHub first, and later they can get to the later time. Obviously, it's good to know what your abilities are. If you fork something that has too many features that you can really maintain, it's better to comment out for now and maintain them at a later time, maybe. Obviously, the best way to keep apps sustainable is to gain money, obviously, to support the continuous maintenance. So you have to treat your product as your app as a product and take it a bit more seriously than it actually is. We've seen apps in the Mac app ecosystem do that. For example, FmpEg frontends usually have a subscription plan. So you have to treat your app's product and make websites and advertise it on social media, make an account. Obviously, collaboration is good. You need to make friends and have people have your back in case you can't maintain the time or you need help for something. And obviously, never be too proud to ask for help or money or advice. It's important to take breaks yourself and set boundaries. You don't really have to reply to all issues right away. You have to take days off. Don't treat it like a job or responsibility or something that you need to respond right away. Don't allow users to DM you on social media about your products. Keep some space between yourself and the app. And finally, know when to give up. Having your app slowly deteriorate to the point where it has a very slow death will prevent people from forking it or contributing earlier, so be upfront about it. So it's difficult to talk about sustainability without speaking about LLMs or AI. And based on the discussions that were going on yesterday on gnome hackers and other rooms, I really didn't feel comfortable having it, but sure. So my opinion is no. I know it's a bit controversial as a topic. I know that it has to be approached in a certain way because the two sides can often get too extreme. I'm not here to shame anyone. I don't think anyone should be shamed, especially if they're required to implement it for their job and stuff. But I think it's important to talk about the negative parts of it. It's important to forget the move fast and break things slogan that goes on Silicon Valley and other groups. We don't really have any investors for the most part. Things can wait. We don't have to ship stuff right away. Users really dislike AI and would rather use something that was made without AI, even if it's worse. From discussions on Reddit and stuff, they really same, I'd say, development, vibe coding specifically. But also fellow contributors sometimes hate it too. We've seen a lot of core libraries and applications banned completely, which creates a bit of friction in the community and how this can be approached. And obviously our volunteer-based infrastructure is not ready to support all the spam waves that come our way. FlatHub, for example, has an AI slop tag. And I'd suggest that you go through them sometime. Yesterday, I saw a submission that was literally empty. It had the source, it was literally a repo which had just written. I don't know. It's important also to talk about the fact that it's mostly a service that can go away at any point. Yes, there's locally run models, but does anyone really use them? Not really. It's expensive too, so I don't know if you want to base your whole app's maintainership on something that can be taken away at any moment. Nobody wants to really maintain slop and infinite depth. We already have code bases that are many years old that nobody wants to touch. I imagine nobody wants to touch 100K lines that nobody really knows how they work, really. And I think that the whole ignoring all the ethical, socioeconomic and environmental problems is really annoying. Our communities are based on political, in one way or another, we stood ground on political issues, even when nobody else knew. So I really don't get the whole ignoring especially stuff that like environmental problems that have conflicting, for example, KDE Eco, which is a nice proposal. So I'd say get involved before it's too late. Maintainers come and go. We saw an important person at GNOME take a break or leave, and many projects were abandoned that need to someday get someone to maintain them. So the best way to never get there is to contribute now. I'd say Q&A, but I'd rather not have a debate about AI now. But sure, any questions? Sure.
Can you go a bit into why you forked instead of taking over the original?
Yeah. The question was why should we fork instead of taking over? I think for the most part you have to notify users that you're no longer the previous maintainer, that you can take different approaches, you have different ideas. Sometimes maintainers just archive the project and are difficult to contact them and to tell them to take over. Maybe you could take over before they archive it. That's it. Any other questions? Sure.
You mentioned like your fork that you renamed
yeah. So I named my fork Scrubber, but the other fork that started had written permission to use the Metal Cleaner branding. And we debated a bit of that with the other maintainer, which, by the way, I think the other maintainer wasn't really into app development, and this got them to start developing for apps, which was a good thing. So yeah, I think Tails is going to update the sources to our fork. And, yeah. Any other questions? No? Thank you. Thank you for having me.
Sometimes starting the fork ends up with taking over. So sometimes starting the fork with announcing what for, like for example, Elix started at ended up being F-Elix for a while, but now it is the Elix.
That sounds good.
Just kind of answering the question.
Pretty long day. We heard a lot of interesting talks about GNOME and KDE. And before we leave, I would like to have the last talk. It will be a little bit different. We'll target more hardware, but like it's also important to have like devices that support GNOME and KDE properly. My name is Petr Hodina. I'm an embedded developer. Mostly do Yocto at Build-Root job. I like Rust. And aim, or why I'm here, is I would like to switch completely from Android to Linux. And unfortunately, like there are some missing pieces. And for that, like I started an app and the whole test suite that I call TaxDoctor. So, before I go into what it exactly is, I would like to discuss the reasons why we need this. The first one is my use case. Like as a developer, I would like to test a new feature and like be certain that I don't break anything, or if I run it overnight, like the CI catches the regression before shipping. Of course, like I don't manufacture devices. When I buy a used device, I would also check like the device is fully working, or at least what's supported on the device. It can be extended also for manufacturers. They could do end-of-line testing or also test the device in field. You can use also the app for conferences if somebody is like interested what already works or doesn't. And lastly, like after you run like the test suite, like you get test report and you can show it to like manufacturers or anybody that should care why you should have mobile Linux devices. So what's TaxDoctor? So it's a small app that you run on the device. It runs a fixed set of hardware tests for multiple subsystems. And at the end, you get a JSON test report that tells you the state of the device. It's local, you don't have to share it. It's aimed as a private report, but you can also publish it to a Git repository. Currently, like I target like post-market Mobian and mobile Nexus devices. I already mentioned like the hardware tests. So what are those? Like currently, like I try to encompass 11 hardware test modules like Wi-Fi, Bluetooth, cellular, GPS, camera, audio, sensors, battery, NFC, touch, USB. Each module runs independently, and you can select which tests you want to run, and you get whether the tests pass or fail, and also detailed results. So the architecture. At the bottom, like you have the real hardware, or for CI, you mock the hardware with mockups and you have unit tests. Then you have like a layer with the modules per subsystem. And on top of that sits a daemon that dispatches the individual tests for the subsystems. The daemon opens a Unix socket, and you can talk to it using like GTK or Qt front end, or through a command line if you need to automate it for CI. One important thing is like the daemon runs on the device, and the UI can also run on the device, or it can run remotely. Yeah, like you have the three front ends, like the GTK, Qt, or pure command line, and what they share is just a protocol in JSON over the Unix socket. The front end does not have any idea about the test. It just queries the daemon, what test it provides, and asks the daemon to run the test suite. When we are talking about the test, like each test is made up from subtests. So like typically, let's say for NFC, you will check like the hardware hardware is present, like on the I2C bus, like in this case it's some NXP chip. Then you check like you have the kernel driver, and then like you check the user space if you have the near the daemon running, or like you can use also the blip NFC or something on top. And if you have all of that, the module will pass. If not, like you get the failure, and you get the reason like okay, like the first 2 steps passed, and then like this subtest failed due to this reason, and like you will know like okay, I need to install like the daemon or run it. One important thing, like since we are dealing with hardware and like we can like publish it to a public database, we would like to also filter out like some device identifiers, like typically each device has serial number, Wi-Fi MAC address, EMEI on the cellular. You don't want to also share your position for GPS or any like attached devices on USB, Wi-Fi, Bluetooth. So for that there's a filter that you can customize, like if you want to filter more of the stuff, it gets filtered. Also, if you are publishing the test reports, you don't want to share any of your, let's say, contact information. So for that, like you generate a random ED25519 key pair, and you use that for identity and also signing the test report, so nobody can like fake it or modify it. So you have like the device, you have the tax doctor or like the daemon and like the front end running there. And once you run all of the test suite, you can send the test report to the database, and that happens through HTTP API. The JSON is validated, and it's pushed into GitDB database. And like you can then take the Git database and generate like JSON files for to go static site to like visualize the test reports. You can try it today. Like I prepared APK and the packages. I built it on GitLab CI and also host the packages then on the taxdoctor.com GPG site. I plan also to upstream it. Yesterday we had a discussion about the app, and like there was idea also like to package it for Flatpak, like have the daemon because the daemon has to be privileged, packaged as a Debian APK file, and just the UI that doesn't have to touch any of the hardware. Let it run in the Flatpak. Yeah, here are some of the ideas from yesterday. So like currently like I use just Unix sockets, so I could use also Warlink. I can package the daemon and ship the UI as Flatpaks, and also like I created the tool for like community around like mobile phones, but it can be extended to literally anything. I also tested that on like the Lenovo X13S laptop that we saw here in the morning. You can use it also for embedded boards, because one of the past jobs was also working with Qualcomm Snapdragon chips that just didn't have the screen and UI, but basically it was mobile chipsets. So yeah, you can take it beyond phones. This application has been up for some time. Like I developed it for like 4 months. We have regular hackathons in Prague, like in SUS offices, and it's been tested like mostly on OnePlus 6, Fairphone 5, Pixel 3 devices, and a few other phones. So now I will show you a demo. I plan to have the presentation fully running from the Fairphone 5, but it's not yet stable, but it has the display port out, so it would be interesting. However, this means like I will reuse the architecture as I was saying. Like we have the daemon and the UI. So here I have the OnePlus 6 running with post-market and Fosh. And on this x86 PC, like I will just run the UI. I also did some localization, or like I asked friends who speak French, German to do some things. Like you can have it also like in different languages. And again, I'm mostly comfortable with English, so I know we are in Berlin, but I will switch back to English. Sorry, guys. And like I could run also the full test suite, but it takes some time, so I will just pick a few of the tests to showcase. Let's see this. Okay, so before I get into the tests, it works that I open Unix socket on the device, and this machine is connected over SSH to the OnePlus 6 and connects to the Unix socket. So that's why I see now, like in the device, that it's SDM845, which is like a Qualcomm device. I just gather like some information and store it in JSON. So this device has NFC, but with the current kernel release, like it's not working. So the first test passed, this one failed, and what happens is like if it fails, like it just tells you, yeah, it failed. Here's the reason. You get the QR code, and like in the payload of the URL or the QR code, you get all the information about like the step, the subtest, where you failed, plus some generic data, like yeah, it was Debian, like it was, or sorry, in this case, like it was post-market OS, and it was this kind of kernel. And this is a little bit more interactive. So like here I have like the sensors, like the Snapdragon has like a separate processor, and it talks to the sensors, and I can a little bit play with that. Here I have like a 3D model for calibrating like the I'm supposed to do the infinite symbol to calibrate it, so it's playing a little bit. Otherwise, like on the background, the goal is more to gather the rates and what kind of sensors the phone supports. This is just kind of gimmick for the user. Then I have a compass, but like this one has, yeah, I put there. There's a little bit bugs, so I won't try to pass that. Yeah, the haptics is also unfortunately broken here, and I think the last one were like the buttons. Yeah. Like the lines that are disappearing, that's like auto advanced feature. So what I can do is just like run all the tests, and I think like in 3 or 4 minutes it will be done, mostly without any interaction. Or for the sensors, I would need to interact, but from the command line I can say I want to run like test suite for CI, so like just get me the data from the sensors and don't validate if I shake it or do anything weird with that. And at the end, like you get like information about the test that you ran and which passed. You can also go back, filter a little bit, and if you ran the full test suite, you can then send it to the Git repo, and basically, as I said, it's a JSON file. So here is basically the results and array of the tests. So this is the device information. Then there's like Wi-Fi, NFC, everything. Like this one is from Sargo, so that's Pixel 3a. As I said, like we use the key pair for signing. So one advantage is I go a bit back. I can like just say, please check in the Git repository or locally the JSON and validate it, and like it will fetch it and like check that the original report wasn't modified, and also like since I push it first to a server and that one pushes it to the Git repository, there's additional like server signature that like yeah, nobody else modified it in transit. Also it has like CLI interface, so you can list the test report and see it on disk, so you don't have to work with it like graphically, and you can have like a batch of devices that you want to test. So that was the demo. We also like discussed yesterday that like maybe the daemon can be integrated somewhere else. Then again, the constructor for it isn't the best name. So if you want and have any suggestions, you can open the link and submit your ideas how it could be called. And that will be mostly all. Like, are there any questions?
Are you considering like having it on typical desktop OSs and stuff like that? Because when you have some like exotic hardware and like with crappy drivers, which may or may not work depending on the day, it's pretty nice to have this.
Okay, so to repeat the question, like it was if I'm considering it to have it also like on the regular hardware, I think like x86, like desktops, laptops, right? Like not servers. So yeah, as I said, like I tried it on, let's say, a laptop, ARM laptop. I ran it also on Mac hardware, Steam Deck, so you can run it, and like it can be also extended, like if you add there a small code to load dynamically the test, like you can just put there the shared object and run anything, right? So it's more, like the project was created because in the past, like I was doing end-of-life testing, like setups like this, and for the phones, like I got tired that like one day it worked, the features, the other day didn't. So it's mostly aimed for the phones, but there's no reason it shouldn't work for anything else. It's more like, well, yeah, it's the one thing I forgot to show. That's like once you get to the end, you have like the JSON test reports, and later you can have whatever UI you have and start comparing the devices, what works, what doesn't, right? So if you would have phones and PCs or laptops, like it would be hard to compare, so like you would just separate it a little bit.
why does the website instruct me to install non-existent package on my post-market OS device? There are no such packages yet, and the slides even say so, but yet the website tells me to sudo APK add Dr.
Yeah, so the question is about the packaging that like you tried that and like it didn't
and
work?
you haven't decided on the name yet.
Yeah, so like the packages should be there, you just need to add the repository to your APK storage. I'm not sure if you have done that. Because like it's not yet upstreamed, right?
Yeah, is there any information on this on the website?
Yeah, there is, and like I can also provide more
on the page
after.
that provides the comments.
Sorry, can you repeat it again?
It's not on the page that provides me with those comments.
Yeah, I can help you later with what you need to do, or you can go to the CI and download directly the APK.
These days, this looks a lot like some LLM hallucinating, so it might make someone not trust the product.
I would say like the that packages come out of CI and they are pushed to the site. Like it's normal Nginx that has the repository for them or APK. Might be now broken. Like I drive it, so like I mostly build it. Like since I also run like Nix, I build it a little bit differently. But we can look into that later.
Just simple templating on the page was probably used.
Well, there's no information that I need to add some custom info.
Yeah, as I said, like in the Git repository, I have the Debian packaging and Alpine packaging, but it's not pushed upstream. So like.
Okay, but on taxdoctor.com I see the comments and there's nothing about it not being in Alpine repos.
Okay, I'll look into that, and if there's missing what to add to the, let's say, Alpine repository, how to import the package, I will provide the information.
Are you planning to eventually make this work on non-mainline Linux phones, for example using Halium or the hybrid?
So the question is if I plan to make it also available on like non-mainline Linux phones, like running Clip Hybris. I was thinking about it, and it's possible, but it's like dividing the resources, and it's not my goal to run it there. On the other hand, I have added at home like a Yola phone, like not let's say the most recent one, but like they were targeting Sony phones. So I flashed there the Sailfish OS, and I'm able to build certain parts, like for example not camera, because here I use lip camera, they don't support it, and I'm able to run the daemon. I'm not able to run the UI because they don't support GTK, and the support for Qt ended at I think 5.15 or something like that, and I just don't want to devote the time. If there would be somebody who would like create like the port for that, sure, but for me it was just like testing the idea what I can target. The Hybris, you can do that, but my aim is like to have fully working mainline phone, and this is distraction kind of.
Do you have plans to distribute these reports somewhere, like a wiki or a place that they can be navigated collectively, so we can
like
test this data?
yeah. So as I was saying, like this one runs locally, but otherwise, if you go maybe let me go here a bit. And yeah, so you have the Tax Doctor itself, that's the app, the Rust one. Then you have the wiki, that's the Hugo site, that's this one. except for the compare devices. I'm still like a little bit tweaking like the design and push it there. And
so this information right here will be on the wiki?
Yeah, it will be on the wiki. And sorry. And the metrics is like a set of Rust tools that build you like the JSON files for the wiki. And as I was saying, the DB has like then the device JSON files plus the signature. One additional thing, since you know like when you are pushing the stuff to the wiki or GitLab and you know something is broken, then like you can create working items, right? And like at least highlight, okay, this isn't working, like if there are like volunteers who want to look into mobile Linux, like hey, people are interested in Shift 6 phone and like the biometrics is not working there. Like the biometrics is not working anywhere nowadays because it's a complex subsystem that requires trust zone. But like the idea is you just don't push the JSON test reports to Git repo and nobody uses it, but like you can automate it and have more insight into the status. Also, like it's not tied just to Postmarket or Mobian. You can use it basically anywhere.
Okay. I might have missed that, but what is the point of the signature you put on the file?
Okay, we have the question about the point of the signature file. So the goal was like when you create the test report on the device, I didn't want to append the signature to the JSON somehow. So I put the signature into a separate file.
But what is the signature for?
The signature is there to validate that, like, you know, I just don't create a database of random number devices, you know.
And where do you get the key assigned with it?
The key is like generated on device, like it's just like a key pair, and you publish the public key to a server that handles the pushing to the database, to the Git repo.
Okay.
Like the reason behind that is like, okay, if you would try to push too much stuff there and like basically make it unusable, like I will rate limit you.
Okay.
Or if like let's say you try different tactic, like I will try to create as many new devices as possible. Like I will say, hey, I trust these developers or these people, and they are allowed to push there. And when you are generating the key pair, I can make it harder for you, like, oh, it's not just key generation, but when you register the key, you need to pass some
So basically,
challenge.
trusted people get a key with which they can test devices, and then you know these people tested these devices, and you basically know you can trust that they tested them properly.
Currently, I trust anybody, right? But like, if
That's
somebody
the idea,
would
right?
misuse it, like, yeah, this is like as a feature for the future.
Okay.
If it comes to that.
Yeah. Thank you.
So I wanted to ask, what is the intended way to use it? Is it more for just like reporting features that are not working, or is it also for tracking features that are working for like more fine-grained, like finding of regressions?
Okay, so the question is, how is, let's say, the test suite intended to be used? So normally it's intended to be used like if you are developing, like you don't have to target the whole device, just like the subsystem you are testing. Or if you are doing release of the OS, you test everything if anything is broken, right? Or if you are doing port to the device and you want to know what is working and you get at least the kernel booting there and you have like at least UART, it's the starting point where you can use it. Like maybe the GPU doesn't work, but like you will detect like some devices, I don't know, on PCI bus or I2C bus that work, but you don't just have the screen or something like that. Or you get everything but the touch screen, like you have a separate digitizer, and sometimes like the only way how to use it is a downstream driver, which is the case for, or was the case for Pixel 3, until you rewrite it, and like you can also like use it to test if it works or not.
I tried adding the repo following the instructions from the week, and it falls for me. So I think the repo supposedly does not exist. Can you? What am I doing wrong? Why does?
We can check it later, like what device you are running and what are you doing.
The website doesn't really help. It links to another. It has links that don't work, links that ask me for username and password, and I don't know what to type there. Links to localhost, export 113. So, well, it's really feels bad.
We can discuss that. Like I'm doing it alone. Like basically, I started with shell scripts and moved like to Rust, and like. If you want to help, like you can tell me what's not working, and I can fix it.
Well,
I can't test everything.
I can't install it, and I'm being given instructions that were not even tested, so that doesn't feel good.
So we can fix the instructions so it works for you. Would that be okay for you?
Well, I don't think the repository even exists. It falls from when I'm just following the instructions from the repo.
So we can check what's the issue later. Any other questions?
So the post-market wiki has a lot of sort of similar data collection, but I guess more manual. Is there thought of combining those two types of sources or working together so the data goes into a common place?
So the question is like Postmarket OS has a manual wiki that has a lot of data, and to comment on that, like yeah, I plan to discuss that, like how we can like cooperate, and like it's not this should kind of supersede it. It's more I see also from the past, like when users or anybody is updating something manually, then it works for some time, but like then they stop, or like the machine die, and the aim of this project is to have fully automated like test reporting. What you do is like you install it with one click, you run all the tests with one click, you submit with one click, and you get everything. Not like, oh, please read like this article, do some magic, and then please post it through MR to the Git repo. So yeah, that's the idea. Unfortunately, like it's a big topic, and again, like there are so many devices, so many distributions. So I hope like we get there soon, but it will take some time. Okay. Sorry.
So then, like as a user, can I just install the tax Docker, and after every update just run the tests to see if anything got broken, and then like submit them to the thread of like possible regressions between your versions?
Yeah, so you install the dep or APK, or you just build it however you want, right? Whatever distribution you have, you run the test, and then you check the test report, the JSON for yourself, and if you feel comfortable, you send it to the main repo.
And so, is it okay if there's like no regression, just like...
It can be also there's no regression, like that's the best case.
It's not acknowledgement of the update, of like everything is working.
That's more like of a, let's say, top layer on Tax Doctor, because it just generates a test report, but it has no idea what broke, right? It's something that will be added on the top, like check the previous test report, compare it. This is not yet there, so it's up to you to decide like if it's broken or not. One additional thing, like since it's still being developed, like and tests are added, some modules, all of the tests are versioned. So if like the test suite changes for the submodule, you just like change the version, and like you can always compare it. So like that's why you don't get, or you get the breakage, right? That like say I'm testing 4 things on the subsystem, and if I add the 5th, it starts failing now, right? Okay. If there are no questions, thank you.
For the presentation, everyone, for all the questions that you asked to our speakers. Well, this is a wrap-up for the first day of LAST 2026. We are going to meet again tomorrow at, let's say, 9:50. We can be here because we are starting at around 8, around 10-ish. Oh my god, I haven't had enough coffee. Not at 8, please, don't come in 8. But yeah, at around 10 a.m. we are going to start tomorrow. So yeah, see everyone tomorrow and later at the social events to whoever is attending.